First of all, we are going to introduce you to the concept of DBMS, RDBMS, SQL, all these things, because you need to understand why do we need to save data and how we can actually save this data. Earlier, where we used to save the data, and now in this era, 2021, where we are actually saving our data, right? The next topic we are going to see is creation of table. So we are going to understand that in Oracle SQL or in SQL, how do we actually create a table? First, we create a table and then we insert the data. So how do we actually create the table and how do we insert the data inside the table? Those all things we are going to see in this second topic. In the third topic, we are going to start up with Oracle. We are going to do the setup and installation. We'll download Oracle. I'll show you the steps from where to download and how to download, and then the installation steps as well. Once our Oracle is ready, we are going to understand the relational model first. We are going to understand selection, projection, and more of the other things about RDBMS, which is nothing but Relational Database Management System. After that, we are going to move to the miscellaneous topics, in which we are going to cover most of the small topics such as alias and then the logical operators. Those all things we are going to cover in this miscellaneous topics. These are some small topics which are very essential if you're learning Oracle SQL. The next topic, we are going to understand the operators as keywords. So all those operators which we are going to learn, how to use these operators as keywords in Oracle, that is what we are going to see in this particular topic. Moving to the next one, we are going to understand what is functions in Oracle. Yes, in all programming languages, we know what is function, but in database, what is function? That is what I'm going to tell you in this particular section. So in this topic, there are a lot of functions which are predefined, and we are going to see how to use those functions to make our work easy. The next particular topic is a very important topic if you think about it in an interview perspective, because in interviews, clauses is one of the topic which has been asked several number of times. So please focus on this particular topic very sincerely, because clauses is such a topic which is very vast and there are so many clauses which you need to work upon. And if you don't practice with clauses, you will not be able to get the output, or you will not be able to learn SQL in a very staggered manner. The next topic is nested query. So we are going to see how to write a query inside a query. Now, if you don't know what is a query, don't worry. In the beginning of the session itself, which is creation of table, I'm going to tell you what is a query, right? Now, how to write a query inside a query, that is what is called as nested query. We are going to look upon that, and then we are going to move to the most important topic, which is SQL commands, which is DDL, DML, DCL and TCL. All these commands we are going to see what do they do, how do they do it, and what these commands syntax are. The last topic, we are going to understand the database objects, some database objects, and stored procedure as well. So as you can see, the agenda topics, if you can see here, is very vast, and there are a lot of topics which we are covering. So sit back and start watching this particular tutorial. It will be really good if you can do the practical things with me in your laptop, so that will become easy for you to understand it within the hour, right? So now that we are beginning with our particular Oracle SQL tutorial, the first topic is introduction. So let's see what is there in this introduction. Now, let's say that we have a particular student in a college, right? And we want some information from that particular student. So what we will have? We'll have his name, maybe his roll number or registration number, and then we'll have some address, right? And then maybe the contact number, right? Or let's say mobile number. So these are some of the information which we want from this particular boy, right? Now, if you can see, these all informations are nothing but what? So these are called as data, correct? Now, why I'm telling you what is data? Because there's a lot of difference between data and database, correct? So now, first of all, we need to understand that what is the difference between data and database. Data is something which is very particular about one person or one particular individual. Now, if you talk about a college with a group of students, and I want those group of students all details, that means I want his detail also, her detail also, her detail also, and his details also, right? Now, obviously, all of these people, all of these students, name, roll number, address, mobile number, I want it, and it will be a huge data, right? That means I have to create some table, and inside that I have to write all these informations, right? To make it look very structured, correct? And that is what is nothing but database. So that whole table is nothing but now database. So if you talk about data, data is one particular information, but database is a group of information, correct? So this is what is the difference between both of these things. Now, if you're very sure about what is data and database, now you must be very sure that why it is called as Oracle database and not only Oracle data, right? Okay, let's move to the next part. Suppose if I ask you that how you will manage this particular data, or how you will manage the database, how will you do it? So let's say that I want to record my information somewhere. So what I'll do, I'll take a sheet of paper and I'll write my information there, right? Correct? But does that sheet of paper will be maintained 20 years after or 30 years later? Will it be the same? I don't think so, right? Because it's just a sheet of paper, correct? Now, how we can manage those data? How we can do that? Now, obviously, in your mind, one answer will be coming, which is computer, which we actually save our data. Right now, also, if you're using a laptop, you have many of your data or information, your music file, video files, images, everything is stored in your laptop, right? Okay, so how to manage? Managing refers to storing permanently and retrieving efficiently. Okay, now managing doesn't mean that you're just storing it, but it also means that you are retrieving it efficiently. Let's say that I have a bunch of students and I want all students' record details to be in a sheet of paper, right? Now, one particular student detail in a sheet of paper is perfectly fine. But when you have 50 or 100 students' details in a sheet of paper, it becomes a little bit messier. Why is it? Suppose that I have a 2 sheet of paper, and in those 2 sheet of paper, I have all the data of my batch of students, all my 50 to 100 students details, right? Now I want to find the detail of one particular individual whose name is Rohan. Now I need to search from starting till the last, where is Rohan detail? And it will take a lot of time. That is what is retrieving. So retrieving the data is not efficient here, right? And that is what we need to also look upon. So a sheet of paper will not work here. Now the question arises is, so then how to store data, a small volume of facts permanently, and how to retrieve, get the stored facts efficiently? Or the another question is how to store database, which is large volume of facts and figures permanently, and how to retrieve those efficiently, right? So these are the 2 questions which we need a solution now. So let's go back to some early 90s or a decade ago, and let's see what happened there. Now we used to use a ledger. So if you know what is a ledger, if you go to a hotel restaurant, right now also in many parts of India, people are using ledgers if you go to a hotel to stay, right? Now ledger is something like a very big and thick diary in which they store all the informations, correct? Now most of the modern hotels and all, they are using tab and pads and obviously the laptops, but many of the places are still using the ledgers. In ledgers, they actually record all of your data and then they use it for next purposes, right? Or to store data efficiently. But now, let's say that I have a ledger and I am storing these particular data of some students in my ledger, okay? Now, in the below ledger, one page has data, right? One single page has the data. But if you talk about the book, the whole book is nothing but the database, right? If you can see, all pages and many books put together forms database, which is large volume of facts and figures. Now, is this a correct idea, or is this a great idea to save our data or to save the database? Let's see. Problems associated in managing data or database are as following. Now let's understand what are the following challenges. So we have security challenges. Obviously, why security challenges? Because to save these ledgers, we have to have a godown, or we have to have some place where security is there, right? And we cannot just assign one security guard to actually look upon all the ledgers, right? Not a very great thought, correct? Now, backup issues. Now, suppose that you have a 10 years ledger, okay? 10 years ledger means a lot of books and a lot of ledgers, right? Now, how you can back it up? That means, obviously, you won't be keeping all those ledgers for 10 years or 20 years in your godown, right? It's just a sheet of paper or it's just a diary, right? It can get rotten or anything can happen based on weather conditions, right? It will not be safe inside, right? So how will you back it up? You can't just make a new diary or make a new ledger and copy all the information in the earlier ledger to this new ledger. You won't be able to do that because it needs a lot of effort, it needs a lot of resource, it needs a lot of employees to do that, right? So nobody will copy all the content of the old ledger to a new ledger, correct? Imagine you are just writing and copying down all the things from new ledger to a old ledger. It doesn't sound good, right? Next is space issues. Obviously, all the 10 years ledger, 20 years ledger, you won't be able to keep it somewhere. It's not a great idea, correct? Human resource issue. Again, you need a lot of people to work around this ledger to keep it safe, to keep the data secured, right? It should not happen like anybody will enter your godown and anybody can change the ledger data. They'll cut your name and they'll write your name. Something like that. It should not happen, correct? So it's not safe, it's not secure. Now, costly. It's very costly because you have to buy the ledgers, you have to keep it safe, you have to have human resources, you have to have most of the people around those ledgers to keep it safe and secured. Inefficient in retrieving facts. If you want to search some of the details, what you have to do? You have to tell the particular people that, hey, I came to this hotel long back ago and I want to search those details. Now, can you please show me? The hotel manager will go to their godown, they will bring that particular ledger down and then they will search. If this is not the ledger, they'll go to the next one. If next one is the ledger, they will again scroll to all of the 100 pages and they have to search your name. And it can happen that we have the similar names like Ritvik many times in the ledger. So you have to find out which particular Ritvik you are, correct? So like that, it will take a lot of effort, a lot of time will be wasted in searching or retrieving the facts or data, correct? So these were all of the issues. Now, computer came into existence looking into these all problems in 1940, right? But computers were very costly, very heavy and very, very expensive, right? So people did not think of using computers, but in late 1950s, computers prices came low as compared to 1940 and people thought of using computer to manage facts and figures. But there were no means to do it. Now, what is the meaning of no means to do it? Let's understand pointer by pointer. Now, in 1960s, high-level programming language developers suggested to make use of programming language to manage, store facts and figures. Now, I think we are close enough to the era that we are talking about, right? But we were having a lot of problems in this particular era also. Let's understand what are the problems. So in programming languages, we use a concept called data type, variables, arrays, right? And one can make use of it to store the facts and figures, right? Now, don't you think that people in that era were having so many problems around using computer or working with computer? People are very happy because computer do not have disadvantages like ledgers, and now they have a way to store facts and figures in computer. And they started to store facts and figures in computer using programming languages. But as the size of facts and figures increased, programming language failed to manage it. So programming languages are also bound to have some limited capacity, and that is why these were also now not very much efficient. Programming languages are successful only in managing data, but not database. Okay, so using programming language, you can save some of the data, but not a huge database. Now, this is where the concept of software comes in, which is database management software. So this is one software which is used to manage and store data permanently and retrieve the large amount of data efficiently, and this is what people were looking for. Now this particular has many examples. Right now we have Oracle database, MySQL database, DB2, Informix, and there are a lot more. So this is one of the particular software which we now use, right? But now understand what is the difference between this and the ledger and the computer programming languages. Let's understand that, because this is what will lead you to Oracle DBMS, and that's how you will actually use that particular software. So suppose we have a ledger and we are saving these informations, right? So these ID, name, age, gender, marks, send, these all are called as fields. So we have all the fields, and then we have all the values, which are also called as data, right? So these are the two main things which we saw in the ledger. We have only two main things which we need to save our data, right? Keeping this fact in mind, people came up to an idea that how we can actually save this field and value into a hard disk of the computer, right? Because all your data will be saved in the hard disk of a computer, right? So a hard disk is nothing but where all the data are saved. Now how we can actually take this field and value and put it inside the hard disk? We can't do it like manually, correct? We can't do it like that. So if I have a hard disk, we can't put this information directly into our hard disk. We need something. We were using programming languages, but programming languages are not accessible to actually capture all the database or all the different data. It is only has limited capacity, and it is only being able to access or store limited amount of data. That's it. So we started to use now, which is DBMS. Okay, so we use database management system software to say that, hey database, can you please do the following things. Now database is having a similar kind of structure which he always maintain, okay, which they always maintain. And if you want to tell the DBMS that, hey, we want to save some data, we have to tell him the procedure how to do it. So let's say the very first procedure is create the table. We need to tell DBMS that, hey, you need to first create the table. Which table? Let's say some name, student table. The field of the ledger should be the columns of the table. Whatever field we have given in the ledger, that is nothing but the columns of the table. That should be the columns of the table. Give a name to the table. We have already given student. Insert the data inside the table. Whatever values or data is inside the ledger, that should go inside the table. Now what you have? You have a table, the column, field names, table name, in which you have inserted the data. This is what you have to follow to keep the data or to store the data present in the ledger onto the hard disk of the computer. Now DBMS will do this and will keep the data saved in your hard disk. This is what happens when you use DBMS. What is the difference between Oracle and then SQL? What is this SQL? We have understood that Oracle is a DBMS software or a database. But what is this SQL then? Let's understand. So when we talk to any person, let's say that she's saying, hi Gokul, how are you? So the person says, hi Sita, I'm good, what about you? What language we are using? We are using English language to communicate with our particular person or an individual, correct? Now, if I want to talk to all the DBMS softwares, all the databases that we have, right? Like we have MS SQL, we have MySQL, we have Oracle, we have Hadoop, we have PostgreSQL. Now, to talk to all these particular databases, we can't use English language, correct? We need to have some language to talk to these databases, to give the commands to these databases, to actually tell the database what you have to do, right? So we have to use here what is called as SQL, okay? So it is a language used to communicate with database management system. We'll be using Oracle database to store our data, okay? But SQL will be the language. SQL will be the actual language which will be writing to tell the DBMS what he has to do. Fine. Now this was all about the introduction. This was all about the historical and the latest trends, what is happening in storing and retrieving data or database. Okay. Now let's understand how does it appear when you are actually storing a data from a ledger to a DBMS, right? Or to your any Oracle or any other DBMS softwares. So if you have a ledger looking like this particular data using SQL will look something like this. Okay, so this is how the table looks like, and this is how the fields are the columns. Understand that the fields ID, name, age, gender, marks and SEM, these are the columns, and the values are nothing but our rows, which you can see here. Correct? Now let's understand what and how to create a table. What is the syntax of it, and how we can actually do something to create a table, which we have seen earlier in our previous topic, right? So let's see what is this SQL command, how to use this SQL command, and what do we call it as. Now, how to insert data into the DBMS by creating the table. So if I have this particular data in our ledger, how we can actually store it in our DBMS using SQL. So this is one of the query which we have to write. Now what I'm saying, what is this word I'm using here? Query, right? Now this query word is very, very important if you're learning database, because query is something which you write to solve a problem, okay? Or query is something which is a problem by itself, right? Query means a problem. So we have a problem. What is the problem? We want this data to be stored in the table. So we write a query. This is the query. We write this query, and once we execute this query, this particular table will be created. Okay, so any particular statement, a set of a statement which you write in SQL is nothing but called as query. Okay, so what we are writing here, we are writing create table student with, we have all the fields in it. Okay, not only the fields, but we also have the data types, plus we also have the maximum number of letters or digits, how much you want, those things. Let's understand one by one. So create table is a command, right? Create table is a command which is, you can say, keywords. Okay, so we have to use create table to create a table in a DBMS. Student is the table name, which you can always change. This is user defined. So if you want to write any other, or you want to give any other table name, you can give it. Now we have the ID, we have the name, we have the age, we have the gender, marks and SEM. Obviously ID, age, marks and SEM, you know that these are numbers. If you see here 52, 26, 98, 8, these all are numbers, right? So we have here number, right? Now ID, we know that it can be only till 10 digits. It should not exceed 10 digits, right? If it is exceeding 10 digit, my table or my DBMS is not going to accept it. So you have given a particular limited capacity to it, which is 10. Similarly, to name and gender, we have varchar2, which is another data type. Don't worry, we will see what is data types and how does it look like, how do we write it in our other topics. But right now I'm just telling you that these are the data types. Varchar2, why is it named as varchar2, not only varchar? That also I'm going to tell you in the topic of data type. 30 and 6. Now these are again limited capacity. If you want to write 6 letters only in this particular gender, if you see male and female, that can be the only particular gender, right? So that is why I've written here 6. 30, the name should not be longer than 30 letters, correct? So this is how you write a particular query. Once you execute this, you will get this kind of thing. Now one thing is missing here, and if you notice, that is nothing but our data, the values. And obviously, because we have not written a query to insert the values, correct? And that is why only the table is created, correct? Now let's move to the next part. So if I have a lot of data in our ledger, how do we do that? So this is another example of employee table, and just have a look, how does it look like, right? So this is how we have the fields, which is employee ID, name, age, address, salary, department and experience. So these are all my fields, and I have just created a table. Now let's understand how to actually insert the data inside this particular table, because now we have the table, but now we need to insert the data also inside it. So let's understand that. So we have a query which is insert into student values. Now understand what is this. See, insert into is nothing but a command. Likewise, we are having create table. Similarly, we have insert into. Student is a table name. Now if you remember, student was the table name which we created. We are using the same table name here. If you write student 1 you have not still created, so it will give an error. So you have to use that particular table which is already created. Then only it can insert values. Then we have the values, and inside the values we have the all values which you want to give. Now understand that the order of all these values should be the same how you are putting it in the creation of the table. So in the creation of the table, if you remember, we were using ID, name, age, gender, marks and SEM. And in the same manner, I am going to put it here also. So we have ID, name, age, gender, marks and SEM, right? This is how you put it. Now some of the questions will come into your mind. The first question is why the numbers doesn't have a single quote, but the names or the gender or the string or character sequence have a single quote. Now that is an interesting fact. In any programming language or in any database language, even if you see, we always write the characters or the strings in a double quote, a single quote, and the numbers is written just like that. Okay. The next question which will come into your mind is, if we have to write the data and if you want to insert the data in the same order, then what if I miss out on some of the data? Suppose if I'm not writing 52, I'm starting from Aman, then what happens? Now what will happen is the SQL will check that what is this Aman. Now he knows that ID can't be Aman, right? Because ID is a number. So he'll put a 0 here by default or null by default, right? Because he can understand that you have not given an ID value. You have started from the name value, correct? But don't do that. If you don't have the data, then obviously you will not be able to write anything in the data. But if you have the data, don't just skip that. Otherwise it will take a null or a 0 value, correct? So this is how I've inserted the data, and now you can see that this is how my table is getting appeared, right? So we have the first row and we have the second row. Understand that for each row you have to write this particular query. Now I'll be thinking that, okay, so if I have 52 rows, that means I have to write all the 52 rows statement like this. And this is very long. This is time taking, right? Then how to do that in a shorter way? That is why we have the Oracle DBMS. So once you will do the Oracle setup and installation, once you will download it, then you will be able to see that how you can easily create a table without writing the query, and how you can insert the data inside the table without writing the query. So without writing the queries also, you can just directly go to Oracle. There's a whole system there where you can just put the values. Once you click on save, it will automatically get saved, right? So we don't have to actually write the queries. But for your knowledge, you should know what are the queries, how to write it, and how will it appear, correct? So for more of the students record, you can see that this is how it will look like, right? So this is one of the great example, very easy example, but now it's time that we move to practical things and we see how Oracle is working, right? So now let's understand how we can actually do the download of Oracle software and how we can install it, right? So before going to the Oracle installation or to the Google Chrome and understand how we can start it, let's understand what is this software and how many types of softwares are like this. So if you talk about Oracle, we have the Enterprise Edition, okay, we have the Standard Edition, and we have one edition for only practicing, for only learning, right? So if I move to our Google and we just write here Oracle download, right? The very first thing which you can see, it is Oracle database software downloads. So if I open it, you will be able to see that we have the Enterprise Edition, which is 19.5. And then if you scroll down, you will find the Oracle Database Express editions, which are 18C and 11G. Now 11G is the Express edition for Windows 64, for Linux, for Windows, and these are only for learners to practice, right? So we'll be using 11G itself. So what you have to do is, once you click on right click, let's say that I am clicking on that. As you can see, this particular database page is not taking me to the download part of 11G, right? That means now Oracle has removed 11G from this particular official website, okay, and they are trying to tell us that you have to go for 18C Express edition. Okay, so if I open this, you can see now this particular two links, which is one for Linux and one for Windows. Now 11G also some time ago, this was also giving me a page something like this, right? How 18C is giving me. In the same way this page used to come, but now it is not. That means they have removed it, and now you can use 18C. So now once you download 18C Express edition, this is having a lot of features which you can use with Oracle SQL Developer tool. Okay, now what is that? So one is Oracle Database and one is Oracle SQL Developer. Now Oracle SQL Developer is a software where you actually write the query and you will get the output, right? In Oracle Database also you can do that, but Oracle is more like a database, as I said. Oracle SQL Developer is a developer tool where you actually write the SQL language and get the queries or whatever problem solution you want, you find it there. Okay, now this particular Express edition for Windows, you can download it. It is for 2 GB, I think. It's written here, it's of 2 GB. It will take a long time, and you can do that. I have already done it. As you can see, Oracle XC 18.4 Windows 64, and it is the same way how your Oracle 11G is gonna work. But the question is, from where you will get 11G, because now you are learning and you don't want to use 18C, right? Once you are very fine with 11G Express edition, then only I want you guys to work on 18C, because it's a little bit of complex. So let's see how we can download 11G, right? What you do is, in Google, just type Oracle Database 11G or Express edition, whatever you want to write, right? When you do that, you will get a lot of websites from oracle.com itself, a lot of links from oracle.com itself, but there are some links which you can see here from O7 Planning, and there are more of random links which you can see, right? And these people, what they have done is they have the .exe file and they have given it, publicly free. So you can click on any of those and you can get it. Similarly, I have done it. You can see here that I have got this particular zip file, correct? Similarly, you have to just download it. Some people are also putting it in the drive and giving it. If you're not finding it, we'll put it in this video description so that you will find this particular software in the drive also. Okay. Now what you have to do? So we have the 11G Express edition Windows 64-bit. What you have to do is we will extract this file here itself. So we are extracting the file and we are getting this particular disk 1, right? Open this, click on setup, and now we are installing. So one message will pop up that do you want to allow this app? You can click on yes, and let's do the extracting and installation of Oracle Database 11G Express edition. So it is preparing to install and it says welcome to the install shield wizard. Let's click on next. Let's accept the terms and license agreement. Click on next and let's click on next. See, we can browse, but I don't want to change the location. I want it to be in the default place. So click on next. Now here you have to set up your password. Now understand that there are two default database accounts, right? One is sys and one is system. If you see enter and confirm password for the database, this password will be used for both the sys and system database account. So I'll be writing a very default kind of password which you should or anybody will not forget, right? So normally for all the Oracle we use a password which is root123. I am just going to put root, right? So that it becomes very easy for me to access anywhere whenever I want to access the Oracle database of mine. So I'm clicking on next, clicking on install, and just wait for some time and it will get installed, right? Now this password you should never forget, because this password will make sure that you're working with Oracle in any of the laptop and in any situation, right? So do not forget that particular password. So as you can see, now we have finished our installation and let's click on finish. So let's go to our desktop. So now we are in our desktop, and as you can see, there's a shortcut which is get started with Oracle database. If I click on it, you will see that I'm getting an error, right? Now the error is Windows cannot find HTTP 127.0.0.1 colon, there's some HTTP port which is missing here, right? So we have to correct it. Now how to correct it? We'll go to our C drive. So let's go back to our this PC C drive, and in this C drive let's go to our program files, and we have to find the Oracle software whatever we have downloaded. Let's move to our program files here. So as you can see, we have got the Oracle exe. Let's open app, let's open Oracle, let's open product, let's open 11.2.0, let's open the server. Now in the server we can see the get started page, right? Let's click on properties, and if you look here we have the HTTP port here, and here what we need to have is, so you need to just delete the percentage HTTP port percentage, not the whole thing. Now let's click on apply, let's click on OK, and let's see whether it is opening or not. So let's double click on it again, and it is opening. So let's see how does it appear. So we have got the home web page of our Oracle, and this is how it looks like. If you can't see, I'm just zooming in so that it appears well for you, and you can see here that we have some things, Oracle database XC11.2, and this is how it looks like. So let's go to our application express, and here it is telling me the username and password, right? So do you remember we have the default username? We have one which is sys, and another one password which we gave as root. Let's log in, and here we are, right? Let's not save the password for now. Now here you can see that we are in our sys, which is our sys or system, right? So we are on our sys database, and here they are telling me that whether I want to create a new database, or I want to use the existing one. So I don't have any existing one right now, so I'm going to create a new one, and to this particular database username I'm going to give Ritvik, right? Or okay, let's say Ritvik, and here also I'm going to give Ritvik. Password I'm going to keep the same for all of the things so that I never forget what is my password for this or that. So for my particular schema we have the root password, and for this database also we have the password which is root only, and I'm just going to create a workspace. Now once you create the workspace, you will get a particular message which is successfully created workspace Ritvik. To begin, click here to login. So I'm going to click here. Now you can see workspace Ritvik, username Ritvik. I'm going to put the password root and click on login. Now this is what is your main thing which you need to work upon, and this is where you will actually start working on your queries, writing the commands and getting the output. So let's see what are these things. So we have to go to SQL Workshop, and once you click on SQL commands, you'll be able to see two windows, which one is this one and the other one is this particular result, right? Now you must have understood what is this. So basically this is nothing but the main place where you will write the query and you will get the result of it, right? So let's say that I'm writing a particular query, select sysdet from dual. Okay, I've written this small command, right? Let's run this. You can see here it is giving me an output which is the system date. Okay, now what is dual, what is from, what is select, you don't worry about that. I've just taken an example and I've given an idea that what is this. So it is giving me the system date right now. What is the date in the system, in my system? So it's 25/8, and that is what it is showing me, correct? So this is how you will write the query and you will get the output. This is where you will do that. Now let's go back to our home and let me tell you something more about this particular page. Let's move to application builder. Let's see what are the things here. So we don't have much of the things here. Okay, you don't have to care about this application builder. Let's go to SQL Workshop. Here most of the things you have to know. Let's click on object browser. Now this is one of the places where all of your tables will be appearing. So if you see, we have all the tables here. We have the imp table, which is by default, it's already created. You can see this is how the table is looking. We have the column name and we have the data type. Remember about the ledger and the table? This is what it is. We have the field names. These all are the field names and the column names. And these are all the data types with all the values. Nullable means whether that particular column can be null or not. So employee number cannot be null, but all the other things can be null. So this is what is my table. If I click on data, I'll be able to get the data. That means the records also. So if you can see, these are all the records of my table. Correct? If you want to edit, you can edit from here. You want to edit the row, you can edit it. So see, you don't have to write the query. You can do it directly. That is what I was saying you. Now, department, DEPT, this is also one of the table which is already given, right? So we have the data. Now let's move to demo users, demo stats, something like that we have. Now let's see how this EMP table appears in my SQL query. So what we have to do is we have to just go to our command line and you have to just write here select star from EMP. Now if I do that, if I run it, as you can see, you're getting the whole data in front of you. That means the whole database. The database which are having one individual data and everything is displayed here. Now you can see more than 10 rows available, increase row selected to view more rows. That means there are more rows here. So what you have to do, you have to do it, let's say around 200. Let's run and you will see all your data. So we have 14 rows which is returned. Right? So this is how you can play with the data. You can get all these data accordingly, and this is what it is, right? Now let's move to SQL Workshop again, and if you can see here, create object is something which is written here, and we have the table, right? Now remember I told you that you don't have to write the query of create table or insert into, right? This is what it is. So suppose if I want to create a table, let's say I want to create a table named as student, right? And the column name I want to give here is, let's say, roll number. I want to give here is name. I want to give here is age. I want to give here is gender. I want to give here is city. So these are the 5 columns which I want to give. Now select timestamp. So roll number obviously will be number. This will be varchar 2. Age will be again a number. Gender will be again a varchar 2. And city will be again a varchar 2, right? Now you can see in all the numbers we have a precision and we have a scale, right? And then in varchar 2 we have the only scale, correct? Let's do one thing. Let's click on next, right? If you can see what is happening, the scale for the column name is required, gender is required, city is required. That means all the particular columns which we have varchar 2, it needs a scale value. It is must that you should give a scale value. So name, I want to give a 30, and gender I want to give, let's say 8, and city I want to give, let's say 10, right? So these are the things. Let's click on next. And once you click on next, you'll be able to get into the next different section, which is primary key. Now what is primary key? What is foreign key? What are constants? Those all things we are going to look upon in the next topic, which is relational database management system. But right now, let's say that I don't have any primary key because we don't know what is primary key, right? And foreign key also will not select anything. So we'll just click on next. Constants also we don't know anything, what is it? So let's create table. Now this is asking me a confirmation that whether these all things are correct which you have written, and it is also giving me a query already written. This is the query which is already written, and this is what I actually showed you in my slide, and we don't have to actually write this particular thing anywhere, right? We just create it and the table will get created. Now what we can do is we can copy this particular query. You can also click on create, you can do that. But right now what I'm doing is I'm copying this particular query, going to my SQL workshop, going to my SQL command, pasting this particular query here and clicking on run. What is it showing? It shows table created. That means now my table is created. How can I check whether my table is created or not? One thing what you can do is you can just write here select star from student. Let's see what happens. Now if I select this particular query and run, it says no data found. It doesn't say that table is not there. It just says that no data found. That means data is not there in this table. Table is created. Let's confirm whether the table is created or not. So if I scroll down, you will see student table, right? And we have the table columns and all, but in the data, there is no data here, right? So if I click on insert row, I will get the detail and I can insert it right now here itself. So we don't have to write the query of insert into and all blah blah. So roll number, let's say I'm writing 1. Name, let's say I'm writing Ritvik. Right? Age, let's say I'm writing 26. Gender, let's say I'm writing male. And city, let's say I'm writing Bangalore. Right? Let's create this. Now you can see one of the row is created. Similarly, you can insert another row and let's say that I'm writing some of the statements. Right? And let's create. So 2 rows I have inserted and you can see it in the data. Let's verify whether it is coming in my SQL command or not. So what you have to write again, select star from student. From now, I think you have understood that what is this select star from student. What I am writing here. Select star from student is making sure that it is selecting all the data from your table and showing it to you. So if I click on run, I am getting my 2 datas, which is Ritvik and for Sachin, right? So this is how you actually play with your Oracle, and I hope this looks very easy for you. Now what we'll do is we'll understand the basic concept, the miscellaneous topics and all those things which I've told you in our agenda, and we'll start working using this particular software. Okay, so now we are done with our Oracle setup, download and installation, and we have seen how to create the table in an Oracle database and how do we actually start creating the table, inserting the values and playing with the data, right? Now, before moving into the miscellaneous topics or the basic concepts around Oracle, we have to first understand the topic, which is a relational model. So let's understand what is this particular topic and what is it about. So let's consider that we have 2 tables and something like this. So we have this one table, which is roll number and student name. So let's say that table name here is student table. Okay, and this particular table is marks table, right? So we have these 2 tables. These 2 tables are separate tables. So let's see the fields. So we have one roll number field and one student name field in student table. So every roll number is assigned with one particular student name. And in the marks table, we have roll number, which is again a particular field for marks table, and one particular field which is marks obtained for marks table. So assigned roll number, people have these marks obtained. Now, if a question arises that, we have a query, we have the query that, let's say we have a problem that we want the details of all the students who have scored more than 40, right? Or who has scored more than 45, something like that. And we want his roll number, we want his name, and we also want his marks. Okay, so you want all his details. Now, considering these 2 tables, we can get roll number, student name and marks, right? Why? Because we have one particular column which is common in both the tables. So roll number is one of the column which is common in both the tables. And because of this roll number, we are being able to say that we are going to fetch roll number, student name and marks obtained. Imagine that this roll number column is not there in this table. Will you be able to tell that how much Rohit has scored or how much Mohan or Sanjay or Kiran has scored? No, right? We won't be able to tell because marks obtained then will not be assigned with any roll number. Correct? So this is what is my problem here, and the solution of this is basically very easy. What we have to do is we should have one particular column which is matching with both the table, and we have this particular column roll number which is matching with both the tables and we can use this. Now, the table which will appear will look something like this. So we have the roll number, we have the student name assigned with that roll number, and we have the marks assigned with that particular roll number itself. So we have this particular table, which is a combined table, the resultant table, correct? And this is what is called as a relational model. What is a relational model? The relation between the two tables, which is the common column. So when you have the common column, you are actually establishing a relation between the two tables. Let's take another example. So we have two tables again here. We have the country and capital. So let's say that this is the capital table and this is country and currency. So let's see that this is the currency table. Now as you can see, country is one of the common column field which is in both the tables, right? So if I'm asking that in Greece country, which capital and which currency is getting used, then it's Athens and drachma, correct? Similarly, if I ask for India, then for India country, we don't have any capital written here in this table and we don't have any currency also written here. So for India, there will be null value for capital and currency, right? But if I ask for Italy, USA, China, Japan, Australia and France, we have all the capital and currency in both the tables and we will be able to get it. This is what is a relational model. This is what is a relational table. Now here are some of the key terms which is related. Let's understand what are these terms. So the first term is nothing but relation. Now what is this relation? Relation is nothing but the table. So now when I'm saying that this is a capital table, we don't say it's a table, we say it's a relation. Capital is one relation, currency is another relation. Tuple. Tuple is nothing but the row. So if I talk about this particular row, Greece, Athens, right? This is one row, which is called as tuple. So now we will not say that it's a row, it's a tuple, right? Next is nothing but attribute. Attribute is nothing but the column. So if I talk about this country and capital, which is my column or field, we call it as attribute. Okay, so country, capital, currency, these all are my nothing but fields or attribute. Now the next one is cardinality. Cardinality is nothing but the number of tuples in a relation. The amount of tuples or the amount of rows in a relation or a table is called as cardinality. So the number of rows in this is 1, 2, 3, 4, 5, 6, 7. So here we have 7 tuples, which is nothing but the number of cardinality. The degree is nothing but the number of attributes. That means number of columns or number of fields. So degree for this relation is 2 because we only have 2 columns or 2 fields, which is country and capital. Okay, domain of an attribute is nothing but the values of an attribute. So if you look about this attribute country, Greece, Italy, USA, China, Japan, Australia and France are nothing but the domain of an attribute. Okay, so these are the list of or set of values, right? The next two terms are very important, which is primary key and foreign key. Now understand this in a very easy manner because this is one of the things which are very important to understand. This has been asked in a lot of interview questions and many of freshers are getting confused between these two. Primary key, what is primary key? Primary key are those keys which are actually uniquely defining your table, okay? So let's say that I have this table which is capital table, right? Now in capital table, which particular column is uniquely defining? Country, okay? Country is all unique. Capital is also unique, but country is one of the particular column which is relational, which is showing relation with the currency table. Because in currency table also we have country. So country is our primary key in this table. Okay. Now, suppose if I have here one more column, which is, let's say, country code. Okay. So we have some random codes. We have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. Something like this we have, right? Now country code is now much more a uniquely identified thing when you talk about this table, because country code can be a primary key also, correct? Let's say that in a school you have a roll number, right? Why do we have a roll number? Because maybe one of the student can have a similar name. Let's say my name is Ritvik, there is another student whose name is Ritvik, but he's Ritvik Kumar, I am Ritvik Raj, right? So to distinguish between these two people or person, which is Ritvik Raj and Ritvik Kumar, we have different roll numbers given, and those roll numbers are all unique, right? And that is what is our primary key in that case. So in all the tables you have to find the primary key. Now if I talk about this particular table, which is roll number is something which is unique, right? So this is my primary key. In this also we have the primary key, which is roll number, correct? Okay. Now we have understood what is primary key. That means in one table we will have one primary key. In this currency table we have one primary key, which is country, right? We have one primary key. Always in one table you should and must have one primary key. Okay. If you talk about a student table, which we have seen in our Oracle database, we have seen roll number, name, age, gender, and then code, right? Or the pin code or the city. So here we have the roll number as the primary key. Now let's talk about what is foreign key. Now understand, if you have two tables, I'm saying two tables, okay? In primary key, each and every table should have one primary key. When you talk about foreign key, we talk about two tables. Let's say relation 1 and relation 2. Now here we have some columns and here we have some columns. Okay. Now let's say that here we have the ID, here we have name, and here we have subject ID. And in this particular relational table, we have the ID, we have the subject name, and we have the subject faculty. Okay. Now understand what is happening here. So here what will happen, ID is my primary key for this table. So for this table also there should be one primary key, and that is subject name, because all the subjects will be different. Okay. So this is my primary key for this table. Why I am not putting this ID as my primary key? Why I am not doing that? Because I know that these two tables are related. And when two tables are related, and if already one particular column is a primary key of the other table, this can't be a primary key of another table. This will be a foreign key of another table. Okay. Why it will be a foreign key? See, if you are living in India, you are localite. But if you're going to Singapore or you're going to USA or you're going to Dubai, you'll become foreign, right? Same thing happens here. When it is in R1 table, ID is nothing but a primary key, which is the local ID, local primary key. But when it goes to the another table, it becomes foreign. A very easy concept, right? So this is what is all about the primary key and foreign key. Now let's move to our miscellaneous topics and let's do it practically, all of these things, and let's start using these terms again and again so that you will get an habit of using it. So now we are in our miscellaneous topics section. Let's see what all miscellaneous topics do we have in Oracle SQL and what are the different topics that we are going to see. So first we'll start with projection, and then we'll move to selection, and then slowly we'll move to some of the very interesting topics in Oracle. Now remember that these are very short topics but very useful, and don't think that these are very small topics, so let's ignore that. No, these are very important topics, so let's understand one by one. Projection. Now projection is something when you want to project something, right? Let's say that you have a college and you have a group of students, right? Now if I want to save data of all the students, which will appear something like this, right? We have USN, name, gender, age, and marks, correct? Now projection is nothing but choosing which column or expression the query shall return. Now suppose that when we want to only present name, age, that's all from one table. Let's say that we have a student table and we want only name and age to be projected. That is what is displaying the result, right? So projection is the process of displaying the result using project queries. So project queries are all those queries which is used to display particular column to the user based on the requirement from the user. So if I want only name and age, that is what I'm giving the command to the Oracle. We are saying that I want only name and age. Now suppose if you are writing that I want the details of all the students whose age is greater than 20. So now you have a condition. Now you want all those details whose age is greater than 20. You are actually wanting those things which you want to project in your resultant table, right? So that is what is projection. Now, if you look in this particular example, write a query to display age and marks of all the students. So I want to display only age and marks of the students. So I'll write select age and marks from student because I only want to display age and marks. This is what is projection. So write a query to display name and USN of the student whose age is greater than 21. Now I want to display the name and USN of a student whose age is greater than 21. So I have a condition. So there we will use this kind of query. Select name, USN, because these are the only two things I want to show. I don't want to show age, but the age of that particular student should be greater than 21. That is what I want. And this is what it is showing. The next is selection. Now what is selection? Now selection means which rows to be returned. That means which all detail or data I want it to be displayed. So selection is the process of displaying the result using select queries. Now let's say write a query to display all the information of a student named Kavita. Remember the table? We have name, age, gender, marks and all. Now I want to write a query to display all the information of a student named Kavita. So select star from student where name equal to Kavita because I want all the details. So I've written star. So select star. This is what is selection. How many rows do you want to select? All the rows I want to select. So select star. Correct? Another example of this is write a query to display name, gender, USN of a student named Ravi. So the student named Ravi, what all things you want? You want his name, gender and USN. That's all. So select name, gender and USN from student. Do not get confused between projection and selection. Projection is the data which you want to display. Selection comes where you want to display that particular row data, one particular row data. That is what is selection. Okay. Don't get much into inside this because any which ways you will do the queries, you will write the queries in Oracle database. You will slowly understand what is happening, why you are using select and why you are using insert, why you are using other commands. Now coming to the next topic, which is case sensitivity. Now obviously in every programming language we have case sensitivity, and in SQL or Oracle also we have case sensitivity. But to make sure that you know where all case sensitivity is required, that is why I have this PPT. SQL keywords are case sensitive. Select case insensitive. SQL keywords are case insensitive. That means select, from, where is, order by, having, group by. These all are keywords and it can be written in capital or small letters. Usually it is written in capital so that it clearly defines that these are keywords. But you can also write it in lowercase itself. Now understand these 4 points. These are very important and keep this in mind till this video ends. Keywords in SQL is not case sensitive. These are case insensitive. You can write it in small letter or capital letter and it will work. Table names in SQL are not case sensitive. Again, table names can also be written in lowercase or uppercase. It doesn't care. Column names in SQL are not case sensitive. Column names are also not case sensitive. That means those also can be written in capital or small letter. It doesn't matter. But the data in SQL is case sensitive. Now this is very important. Data is case sensitive. Why? The reason is, suppose if you are saving one particular data as Ravi, which is small RAVI. Now if you are asking for a particular data which is capital RAV small I, obviously these two are having much and many more differences if you can see, right? Name is same, but the writing pattern is different. Now this Ravi can be different person and this Ravi can be a different person, right? So when it comes to data, data should match. The data, letters, capital, small, lowercase, uppercase, these all things should match. If it is not matching, then you will not get a result. So make sure that you know in any database languages the data is case sensitive. Other than that, everything is case insensitive. Let's move and let's see one of the examples. If I'm writing select name age from a student where name equal to Ravi, if you can see select is a keyword, it's case insensitive. I've written it in a very different manner here. Name age, these are fields. From is a keyword, student is a table name, where is a keyword, name is a field. These all things are case insensitive, but when it comes to Ravi, which is a value, which is a data, is case sensitive. So if I write here small RAVI, this output will not come. Because it's capital RAVI, that is why it is showing me capital RAVI. Okay, so these are nothing but my keywords, and this is my table name, and this is my data, and this is my column name, right? So this is what is all about my case sensitivity. Let's see one more example, which is select name age from a student where name equal to Ravi. Now this is wrong. If you can see, this is wrong data. So no data found, right? Now coming to the next topic, which is data types. So what all data types do we have in our database language? A data type specifies a particular type of data. We have already seen one or two data, which is number and varchar2. We have some more, which is integer, floating point, boolean. We will see one by one what are those. Now if you look here, we have in character data type char, varchar2 and varchar, and then long. In number we have the float, and in date we have date data type. That's it. So these are some of the built-in data types which we have in SQL. Let's understand one by one what are the different features which they provide. So in char, it's a fixed length character size. Okay, that means how much ever value you will give to this char, only that much letters or characters can be kept. And the maximum size is 2000 bytes per row. Default size is 1 byte per row. Varchar and varchar2, these are variable length character data. That means it can be increased. Character is a fixed length which cannot be increased. Now, what is the difference between var and varchar? Now, if you look here, the amount of bytes is what is the difference. So it can store up to 2000 bytes per row, but varchar2 can store up to 4000 bytes per row. Okay, some more differences are written here, but I'm not going to take that because this is not that much important. Varchar and varchar2, if you know the difference of the memory size, that's enough. So people generally use varchar2 because that is what is having the most bytes per row. So that is what they use. In number, we have two things. If you remember in Oracle database also, I've shown you two things. So you can see varchar we have a scale, but in number we have precision in scale, and that is what it is showing here. So we have in number precision and scale. Precision goes to 1 to 38 and scale goes from -84 to 127. We have similarly float and then date, and for date we have the normal format, which is DD, MMM and YY, and this is what is the date format. If you want to use it, you have to use this parameter NLS date format to use the date property. But generally we don't use these all things. We use it when we want to give date particularly, but even with number, dates can be written, and generally we use number, varchar2 and char. That's it. Okay, let's move to the operators. And in operators, we have a lot of operators which we use in Oracle, but the most common ones are plus, minus, multiplication and division. Now, why these are common ones? Let's understand. An operator is a reserved word or a character used primarily in an SQL statement where clause to perform operations such as comparison and arithmetic operations. Arithmetic operations I have just told you. These operators are used to specify conditions in a SQL statement and to serve as conjunctions for multiple conditions in a statement. What is this? What have I read so much long? Now understand, if I go to my database and if I say that let's go to my SQL workshop, let's go to my object browser, let's go to my EMP, we have a salary section here, right? If I look into the data, we have a salary here, right? Now suppose that to this table, I want to write a code to which I want to say that I want the names of the employee with their salary increased by 1,000 rupees. I want the salary to be increased by 1,000 rupees. How we will do that? So let's say that I'm going to SQL commands and I'm writing a query, right? Let's say I'm writing select name from EMP, right? This is what I have written. So, okay, I think it's not, it's e name, it's not name, right? So I am getting all my e name. Can you see? I'm getting all the e names, correct? Now, what I'm going to do, select e name from EMP. Here, what I want to do is, I want to use the operator and I want to say that the salary, what I want, it should get increased by a 2000 rupees and then show me the table. So now the king, which was having 5,000 as a salary, now is increased to 7,000. Similarly for Blake, it is now increased from 2,850 to 4,850, right? Similarly for all of them, the salary is increased with 2,000 rupees. Another question. Let's say that somebody is asking you that I want employee names with their annual salary. That means in a year how much they are making. So what you will do? You will actually do multiplication with 12 because you have 12 months. So salary into 12 will give you how much? The annual salary. So this is nothing but your 60,000 rupees for King. For Blake we have 34,000 and then for Clark we have 29,000, right? So this is what is their annual income. Half annual income 6. Let's multiply it with 6 and you'll get half yearly income, right? This is where we use the arithmetic operator, which is plus, minus, divide. Whatever you want to do, you can do it from there, right? The precedence is given here, plus, minus, multiplication and division. So BODMAS rule you already know. This is what we use. Now let's come to the next one, which is column alias. Now what is this column alias? Remember that we all have one nickname, correct? So if a guy named as Shivam Agarwal, his home name or house name will be something called as Monu, right? Or anything else. Now in SQL also, when we create a table, sometimes we give a column a very big name, right? Or a table a very big name. And when we actually write a query every time regarding that table, we always have to use that table name or column name, which is very long and it's very tedious. So what we do, we actually make another nickname for that particular table or for that particular column name, okay? So let's say that I have USN name, gender, age and marks, okay? Now I think that USN should be changed to registration number. I think that age should be changed to years old. And I think that marks should be changed to score. So this is what I have done here. And this is what is called as alias, okay? Alias means that a temporary name to a particular column field or to a table name, right? Now how to do this? So we do this using two methods. We actually use as a keyword or we directly write it like this, right? So generally you must have seen that employee E1, employee E2. Why do we do that? Because I don't want to write employee every time. I want to make it a shortcut. I want to write E1, E2, something like that. So the alias name will never be reflected in the actual table. These are just the temporary names, not the actual names which is present in the hard disk of the computer, okay? So how do we write it? Select USN as registration number, name, gender, age as years old, marks as score. And this is how you will get the result, right? Let's move to the next one, which is distinct keyword. So I want the data which is distinct. Let's say that I have this table and I want the data of distinct age. That means not the repeated ones. So 21 is repeated twice, 22 is repeated twice. I don't want it to display twice. I want the distinct data. So I want 121, 120 and 122. This is what you will get. Okay. This is what is distinct. So how do we use this keyword? There may be a situation when you need to retrieve unique records and not multiple duplicate records. So you want unique data. This time we will use distinct keyword. It is used to avoid displaying repeated values. So select distinct age from student. All the unique age will be shown from the student table. Next one is concatenation operator. And concatenation, if you remember, in any programming language, if you know, concatenation is nothing but joining of two things, right? So the operator, double pipe operator, is used for concatenation operator and is used to combine multiple data or multiple column. So if I have this table and I want to use name pipe operator age, that means these two columns will be combined together. So, but I want to use it as a alias name, which is name and age. So this is where I'm using the alias. Okay, I don't want it to display as name pipe age. I want to display it as name and age. This is the column name. Okay, now this is what is the answer. Ram 21, Ravi 20, Kavita 22, Arjun 22, and Anjuna 21. This is how you get the concatenation done, right? Now, one more example of this, if you can see here, these all are nothing but the concatenation. Now see what I'm doing here. Name concatenated with aged. Aged is not a column field, it's a string. So let's say the name is Ritvik. Then it will write aged. Then it will write my age. So this is what will get printed. Ritvik age 26. Amazing, right? Okay, so this is what is concatenation operator. Now comes the very interesting topic, which is dual table. So dual table is a default table which is defaultly given by Oracle, and this particular table is by default present. You can use this anytime to do any task. Now the dual table is a special one row one column table. So if I want to show you how the dual table looks like, have a look. Let's say that I'm writing select star from dual. See, I have not created any dual kind of table, but still it shows me one row, one column. The column name is dummy and the row data is X, right? And this is what is dual. Okay. Now what does this dual do? Let's understand. So dual is nothing but kind of a practice table where you can do whatever you want, right? So let's say that I want to print system date. So we use sys date, which I've shown you already, right? Now, if I want to see the description of this dual table, so what I can do is I can just write description dual. That's it. Now you can see what is in the description. Table name is dual, column is dummy, data type is varchar2, length is 1, nullable, yes, it can be null. And this is what is the dual table description. How can I look into any table's description? DESC is the keyword for it. Correct? So want to see how dual table looks like? So we use description. Okay. You can also check the system date from the dual table using the following statement. And you can also check the arithmetic calculation from the dual table using the following statement. Let's say I have some formula and I want to execute that, or an equation, I want to execute that. So this is what is the dual table will give you. So it will give you the answer, whatever answer will come. And this is what is my dual table. So this was all the miscellaneous topics around SQL and Oracle database. Now we will jump to the new topic and let's understand what all things are there in that topic. So now we are in our next topic, which is operators as keywords. And in this particular topic, we are going to understand what are the different operators which we can use, and also the operators which acts as a keyword in Oracle database. So first of all, we are going to understand the relational operator, which we already know, like the less than, greater than, equal to. Those are nothing but our relational operator, something like this, right? We also have not equal to with 3 symbols. So don't get confused in Oracle. Not equal to is actually denoted by 3 symbols, which is exclamation mark equal to, and then if you're using less than, greater than together, and then the exponent and equal to together. These all 3 symbols are nothing but not equal to, so don't get confused. And these particular relation operators are usually used when you are comparing two values in a condition, correct? I'll show you some examples also. So let's say that we have this table which we are using from the starting, USN name, gender, age and marks, which is a student table, and we have to write a query to display USN name and age of all the students whose age is equal to 22. So condition, but based on comparison, right? That we use relation operator. Write a query to display USN name and age of all students whose age is greater than 20. Again, comparison, relation operator. The next question, write a query to display username name and age of all the students whose age is lesser than 22. These are some questions. You guys can do it. This is very easy. You have to just use the operator and that's it. You will get the result. So try to create, as I've already told, try to create this particular table and try to solve these questions. Next question can be, write a query to display username name and age of all the students whose age is greater than or equal to 20. This also you can do. Lesser than or equal to 22. This also you can do. And whose age is not equal to 20, this also we can do. So in this particular last question, which is age is not equal to 20, you can use any of the three symbols. Try to do it on your own. Try to see whether you're getting the answer as imagined or not. Yes. So this is what is your precedence operators. So first we give precedence to equal to, then greater than, less than, greater than equal to, less than equal to, and it goes on. Correct? Operators has keywords. Now this is very important and this is why this topic was discovered. So the very first topic which here comes in is between and operator. Okay. Now what is this between and operator? Now let's say that I have the relational operator and I want the age greater than 20 or lesser than 20 or equal to 20, right? But what if I want that the age should be between 20 and 22? Then what will happen? Correct? So how do we solve that? To solve that, we will use this kind of operator which acts as a keyword. So we don't actually use the symbols or something, but we use a keyword to do this. When the condition has a range of values to be compared, we should be using between and operator. Write a query to display all the information of the students whose marks is in between 80 and 90 from the student table. So all the students whose marks is in between 80 and 90, we need to use between and. So select the star from the student where marks between 80 and 90. So all the student details who have got the marks between 80 and 90, the details are getting displayed, right? If you now look upon this particular screenshot, we have written select the star from the student where marks not between 80 and 90. Now we don't want those values which are in between the range, but we want those values which are outside that range. So we have to just use not between. Okay. So if you want the values to be inside the range, then we directly use between and. But if we don't want the values to be in that range, then we write not between. Similar case, if you use higher value first and the lesser value later, then you will get a result of no data found. Okay. See, you are writing between 80 and 90. That makes sense because 80 and then 90. But if you're writing between 90 and 80, it doesn't make sense to Oracle or to SQL. So it will say no data found. Now, whenever comparison has to be done with respect to set of values, we have to use the in operator. Okay. And in operator, what happens? We have to write a query to display all the information of the students whose age is 20 and 22 from the student table. So you want all the details of the students whose age is 20 and 22. So have a look. So in range, now understand the difference between and in. In will give you a range which will include only those data which you want to see. So in the bracket of in, you will only put that value which you want to see. There is no range as such. But in between and we have a range. We have 80 to 90, 90 to 100, something like that. This is what is the difference between and in. Okay. So we use select star from student where age in 20 and 22. The students who is having the age of 20 and 22, we use in operator in that. Right? Okay. Now the next one is like keyword. Now like keyword is very interesting keyword. Why? Because this is very useful in many of the SQL queries. The like operator is used to search for a specified pattern in a column. So let's say that I have a particular student table in which there are many students' names. I want the student table to sort out. That means in alphabetical manner. So all the names starting from A should be above, then B, C, D, E, F. I want to sort it out. How we can do that? We can use like operator. Okay. So suppose I want all the A people names above. So how we will use that? See, there are two pattern matching symbols in SQL, percentage and underscore. Percentage is also called as modulus. It matches 0 or more characters. So it either matches 0 characters or it will match more characters, not 1. but underscore it matches exactly one character. So suppose I have one particular name which is Raj and I have one particular name which is Ram. Okay. And if I'm writing RA underscore, so underscore is only taking one character. So in that case, RA underscore will give me Raj also as the output, Ram also as the output. Okay. But when you talk about modulus, then RA modulus, if you write Raj, Ram, then more names like maybe Rat, maybe some other name, those all things will come into picture. Let's take some examples. So write a query to display all the details of the student whose names starts with RA, right? So all the names which is starting from RA, we are getting the output, but we are not using underscore, we are using modulus. That means 0 or more characters, not 1. So either 0 or more characters. So we have one character M and in another name we have VI, 2 characters, right? So more characters. Write a query to display all the details of the students whose name's fourth character is I from the student table. Whose name's fourth character is I. Only one character we need to find, so we need to use underscore. So select the star from student where name like. So now we need to find all the previous 4 characters, but we know the fourth character is I, right? So we'll use 3 underscores and then a I. Why 3 underscores? Because we know that the fourth one is I. So the previous 3 letters we need to identify. And that is what we have done. So we are getting Ravi and Kavita because Ravi and Kavita is having the fourth letter I. This is how you will use the like keyword. Now next one is null. Is null, by looking into and reading the name you must have understood what is it. Let's understand what is null. It is used to select only the records with null values in the column. Only the null values in the column will be there. Write a query to display all the details of the student whose age is null from student table. So let's consider a new table because in the previous table we were not having any null values. So in this table we are considering a null value which is in 125 USN and 126 USN. So we have a particular age value where null values are there. And we need to write a query to display all the details of the student whose age is null from student table. So what will be the query? The query will be select the star from a student where age is null. Wherever the age is null, that particular detail will be shown to you. Now, next one is logical operators. Logical operator we already know in many of the programming languages we have and, or, and not, right? We also have this particular logical operators here in our Oracle and SQL. So in write a query to display all the details of the student whose marks is greater than 85. Now understand that this is one part of the question. Write a query to display all details of the student whose mark is greater than 85. And their names should be not start with R from a student table. Don't you think we should use here like operator? And don't you think we should use here the relational operator? Right? Now, there is one more thing which is AND. So we can use here logical operator AND. Right? Let's see what will be the answer of this. Select a star from a student where marks is greater than 85 and name not like R modulus. Because we don't want the R names, the names starting with R. Right? So we are getting all the names which is not starting with R and the names are scoring greater than 85, right? So these are the questions, these are the ways the question will be asked, and this is how we have covered the next topic, which was operators as keywords. So now we are in our next topic, which is functions. Let's understand how and what are the functions which is used in Oracle to make our work easy, to write our queries easy, right? Now, before moving into each one of the functions, we should understand that there are 2 types of functions. One is your single row function and one is your multiple row function, right? Now, in SQL, these 2 functions are basically used. And what is the meaning of single row? What is the meaning of multiple row? We can understand by its name itself. Single row means which particular functions will accept a single row as an input, okay? Or it accepts multiple rows as input, but produces one result per row, okay? So let's say that we have some of the functions which is only giving me the result of one row as an output. That's it. That is what is single row. Multiple row is when it can apply it to multiple rows and it can give me the result of multiple rows. That is what is multiple rows. Now once we will move to the functions, you will be able to understand what that is mean. So first we will understand single row functions. There are a lot of single row functions. We'll first complete that and then we'll move to the multiple row functions. In multiple row functions, we have some aggregate functions, which we also call it as group functions. So these are nothing but sum, max, min, count, average. Now these all functions are multiple functions, and these are some of the functions which has been asked a lot of time in many interviews. So let's start with the single row function and let's understand what are these. So first of all, we have this particular function, write a query to display name of all the students. So we need to display all the name of these students in lowercase letters from the table student. So we want it in a lowercase letter. So we have this particular function which is lower, Lower, that's it. And whatever column we want to present it in a lowercase, we write that in the bracket. So select lower name from a student, right? So we got this particular output. Okay, so this is nothing but single row functions. Let's move to the next one, which is write a query to display initial letter capital of data Ritvik. So I have a data Ritvik, okay, and I want it to be written in such a manner that the first letter only should be capital, right? So we will use init cap, which is initial capitalize, right? So this particular init cap method or function will present me this output in which the first letter is capital. As is nothing but alias, because I want the column name to be initial, I have used the dual table here, okay? The next question is write a query to display all the names and gender of the students in lowercase where gender is male. Now understand the question very clearly. I want to display all the names and gender of the student in lowercase. So first of all, name and gender should be using lower function. And then the condition is where gender is equal to male. So this is what is the query and this is what is the output we are getting. The next question is write a query to concatenate data Ritvik and Raj. Now one of the ways to do it is this one. You already know that we can use the pipe operator to do this, but we also have one concat function which we can directly use to do the same. So both things will result into same thing, as you can see down, right? The next function is write a query to find the length of the string. So if I want to find the length of any string, we'll use length function and it will give me the length of that particular string, right? The next function is write a query to display the substring of the string Sudeshna from third position, extract 6 characters. Now understand this question very clearly. There are a lot of information given and you should be able to use all this information when writing the query. We have the string Sudeshna and it wants from third position extract 6 characters. That means there is some function which uses these 3 parameters. So we have a function which is substr which uses 3 parameters. First of all, the string with which you want to play, and the second parameter is nothing but the position from where you want to start the extraction. And the last parameter is nothing but how many characters you want to extract. So it will extract Deshna because D is my third position and from there 6 characters are DESHNA, right? So this is how the substr function will work. Let's move to the next function, which is write a query to display the position of the character A in the string Chatterjee. Okay, so what is happening here? See, we want one character position from the string. So A is one character, the position of that string is 3, we know that. But how can we tell the Oracle or SQL that, this is the position of A character? So we use in str, okay? In str will make sure that you get the position of the character from the string. So we write the string as the first parameter and then the character as the second parameter. Let's move to the next questions. Write a query to trim the leading A in the string Akash. Akash is a string and we want to trim the leading A. Leading A means the very first A because we have 2A in this name and you want to remove the first A. That's it. Now if you see, select trim method we have used leading A from Akash. So when you write like this, it understands that you want to remove the first A from the string. If you want to remove the next A, then you can see here what is happening. Now this is not the next A, this is exactly the last A, okay? So write a query to trim the trailing A in the string, okay? So don't think that in between whatever A is coming will be removed. No, the last A will be removed. So if you see trailing A from Angelina, so Angeline will be the answer because last A is getting removed. If I write here leading, then answer will be N-G-E-L-I-N-A, correct? This is what is trimming. Now let's move to the pad. Now look here what is happening. Write a query to display the data Ritwik in the format at Ritwik. That means 4 prefix ats and then Ritwik. How to do that? This is what is left padding. So if you see, we are using L pad and we are writing Ritwik. The total characters should be 10 and which character I want to add? At. Which side? Left side. So I want to add at the rate in the left side of the string and the total amount or total length of the character should be then 10. So this is how LPAD works. Similarly, how RPAD will work, it will move the @ symbol to the right of the string and the total length of the string is 10. So this is what you will get the answer. Not only at the rate, but if you want to put any other characters or letters or symbols, you can do that with it. Okay, now we are in our math functions. So have a look what is happening. What would be the output of the following query? Select around 95.528, 2 from dual. 95.528 is a number in which I'm using the round method and I'm saying that it should round it close to 2 decimal places. So 95.528 will become 95.53. But what about trunk? Now understand, trunk is nothing but will truncate. So 135.256, now we are not using round. So it is not rounding. It is just truncating and making my decimal place to 2, which is 135.25. Okay, so these are math functions which are really very important. Try to understand in a very good manner. Okay, next one is mod. So what does this do? Now modulus, if you know, it actually gives you the reminder, right? So mod, if you use 60 by 2, so obviously no reminder will be left, it is 0, right? Same manner, write a query to display the age. If age is null, replace it with 0. So do you remember one table where we were having age where it was having null values? So if any null value is there, normally that is displayed using a dash, right? But what do we want? We want that it should be getting replaced by a 0 wherever null value is there. So if any null value is found, we have to replace the age value with 0. This is what is done here. The next question is, write a query to display the age. If age is null, replace it with 0, else replace it with 28. So if the value is null, replace it with 0. Otherwise, replace the value with 28. So all the other values are replaced with 28, right? This is what is NVL2 and the previous one was NVL, correct? Null value logic. Fine. Let's move to the next one. Now these are the date methods. So date functions, how do we use it? Write a query to display the number of months between the dates 24th December 2018, 24th March 2018. How many number of months are between these? So we use months between method, right? We can also use between and, but months between will give you an exact answer. If you see here, 24th December 2018, 24 March 2018, and it's giving me 9 months, right? In the same manner, if you want to add some months to a date, so if you want to add 7 months for the date 24th March, so you will write like this, add months method, 24th March 2018, I want to add 7 months to it, it will become 24th October 2018, right? The next one, if you want to find the next day of a given day, so write a query to find the date of the next Friday after the date 14th Feb. So after the date 14th Feb, what is the coming Friday? That's 21st Feb. How and what method we have used? Next day. Easy. A very easy and simple method names are given here. Now, Oracle null if function accepts 2 arguments. Now understand this. It returns a null value if the two arguments are equal. So see, null if 100 and 100, it returns a null value if the two arguments are equal. So it is returning a null value, two values are equal. If the two values are not equal, it will return me the first argument, right? This is what is null if. So what is the benefit of this? The benefit of this is that if the two values are equal, it will let you know that those values are equal. And if the two values are different, then it will return the first argument. Okay, now we are close and coming to multiple row functions, but this is the last one in single row. So these are nothing but the format of date format. Write a query to display the name higher date, where the higher date should be displayed in the format DDMM. Select name because I want that, and then higher date also I want to show, but in which format? DDMM, that means date and month. So I have to obviously change this higher date format to character. So I'm using toChar method. This is very important. Again, I'm repeating, the higher date is nothing but what? It's a date format. I want to change this to character date. Why? Because I want to display it in another format. So toChar. Okay. Let's say that there's a number. Let's say write a query to display name and salary. The salary should be displayed in the format of $99,999.99. What is this? Salary, you already know that's a number. Now I want to represent into a character because I have a dollar here. Can you see? And dollar can't be counted in a number. So we are changing it to character. So we are using toChar. Right? So whenever you want to change from one particular data type to another, you use toChar, tonum, toDate, to these all things we use when we want to change the data type from one data type to another. Okay, so now is the time that we should move and understand multiple row functions, and from here we are going to discuss the multiple row functions, which are count, max, min, sum and average. So write a query to display count of all the rows present in student table. Count star, very easy. You will get all the rows present in the student table. Write a query to display the count of a distinct age. Like that means distinct values are how many, not the duplicate ones. So distinct values are 6. 2 are duplicate. Okay. The next, write a query to display the minimum of all age present. Min age, very easy. You'll get the minimum age. Maximum, max age. You'll get the maximum age. Right. The next is sum. So sum of all marks, I'm getting here 694. Average of all marks, I'm getting 86.75. Right? Very easy multiple row functions where we can directly use the function to calculate the count, the sum, the average, the min and the max value. These were all of the functions and methods which were used in Oracle and SQL. Let's move to the next and very important topic in SQL language or Oracle database, which is clauses. So let's understand now what are clauses and why this particular topic is very, very important. Now, when you talk about clauses, we have a lot of clauses which we can use in our SQL language, in our Oracle DBMS database. Now, these clauses basically tells us that what all conditions can be used and how. So let me give you an example. Write a query to display all the details of all the students in the order of age from student table. Now, if you look here, this question is a little bit unique other than all the other examples which we have seen till now. Because if you look at this particular table of a student, the question is to display all the details of the students in the order of age. That means now we don't have to actually check whether the age is greater than 20 or less than 25 or equal to 20 or in between 20 and 25. Not like that. We have to now understand and give the result in the age order. That means ascending order of the age. So first 20 should come, then 21, then 21, then 22, again 22 and then 25, something like that, right? So then we should use some of the clauses. So let's see which is the first clause. The first clause is order by. Now the output of the SQL query can be predicted, but the order in which the rows get displayed cannot be predicted, right? So till now, whatever examples we have done, you have seen that the order is very random in all the results, right? There's no particular order in which the result is coming. But now, because we have the order by clause, When we use order by, we will get all the results in a order, ascending or descending. Now, what is the syntax of using this order by? So we use order by and then column name. If you want to do it in a descending order, you have to write the particular term DESC. It will come it as descending. But if you want to use it in ascending, you don't have to write anything because ascending is by default. Even if you write ASC, it will give the default ascending order. Okay, so you can see here that I'm getting the ascending order in the result 20, 21, 21, 20, 22, 25, and then the null values. So the null values will come at the last because Oracle is confused whether null should come before 20 or after, so it is putting it after. Now the next one is group by. Let's understand what is this group by clause. Suppose that I have a question, write a query to display age and the least marks scored by each unique age student from the table student. Now understand the question, it sounds very difficult but it's very easy. We have to display the age and the least marks scored by each unique age student. That means now we are not actually wanting a duplicate value. What we want, that we want the age group student who is having the same or similar age. We want them to be grouped in one group. So let's say that I have 5 students, 2 of them is of age 20 and 2 of them is of age 21 and 1 of them is of age 22. So I'll group the 20th age students in one group. I'll group 21st or 21 age students in one group and the 22nd one student, which is single student, in one group. Okay. And now in all these groups, I'll check which particular student is having the least marks scored. That means in the first group where I have the student whose age is 20, I'll check with both of them that who has the least score. Okay, something like that will happen. So if you look here, select age, comma, min marks. That means minimum marks from student group by age. Okay, so see, now no repeated data is coming. 22 was repeated, but I'm only getting 87. Why? Because 22 was having 2 marks, 90 and 87. I am getting only 87. I'm not getting 90 because 22 age group students were in one group and the least one is 87. Now if you similarly look at 21, we have 2 marks, 75 and 85, which is the least one, 75. So 75 will be recorded. Can you see here? And then 20 and 25 was alone, so they have 85 and 88, and the null value was also 2. If you look here, null value was also 2, 89 and 95. 89 is getting displayed because that is the least one. So this is what is group. When you have similar value, same matching value, you group that particular students or that particular data in one group, and then you can apply some conditions on that. So these are nothing but the clauses. Let's see one more example. Write a query to display gender and the least marks scored by each unique gender student from the table student. We have only 2 gender, male and female. Both male and female will be grouped together. So there will be only 2 data, 2 rows will be shown. Can you see this? So from the male, the least score is 85 and from the female, the least score is 75. Okay. Similarly, if you look at this particular statement, what we have done till now, skill group by clause is used in collaboration with the select statement. We have always used the select statement whenever we have used group by. To arrange identical data means unique data into groups. The group by clause follows the where clause in a select statement and precedes the order by clause. Now this statement is really very important. See, we have so many clauses and all the clauses have some order to write. Okay, you can't just write order by and then you're writing where clause, or you're writing where clause and then you're writing order by and then you're writing group by. You can't do that. There's a certain order in which you have to write it. So the group by clause follows the where clause. Okay, that means after where clause, group by will come in a select statement and precedes the order by clause. So group by clause precedes the order by. That means the real sequence of order of these are this particular order. So the group by clause follows the where clause in a select statement and precedes the order by clause, right? So this is how you will actually arrange your particular query. That means if you have one question in which you have to use the group by also, the where also, and the order by also, then you have to use these three in the same similar manner. You can't do shifting of these here and there, otherwise it will give error. The group by statement is often used with aggregate functions, count, max, min, sum, and average, to group the results set by one or more column. Okay, now that we have understood the order by and group by, there's one more clause which is having clause. Okay, but I'm not gonna show you that right away because I have something extra to tell you. Now there are three clauses which we have seen. Actually there are four, which is where, order by, group by, and having, right? Now why I'm not showing you the having clause, because there's a very big question in the IT industry that why we have having clause when we already have group by. Because having clause, whatever it does, it can also be done by a group by. Then why is the need of having? Now understand that group by is often used with aggregate functions, but having clause cannot be used with aggregate functions. This is the main difference why do we have having clause, and we'll understand what are the other differences which makes it distinguish between group by and having. Okay, now let's move to the having clause and let's understand what is there. Okay, before that, just one example of group by. If you can see, select gender, max marks from student, group by gender, right? One more question from group by. Write a query to display age and count of the age for all the students whose age is equal to 21 from the table student. We are using count, that means we are using multiple row function, that means aggregate functions, and this is also used only by group by. So we have this, select age, count age from student where age 21, group by age. Okay, so wherever the count is, wherever the age is 21, show me the age, show me the count of those age. There are two students whose age is 21. That is what I'm getting. Next, write a query to display age and the maximum marks scored by each unique age student from the table student. Same kind of question, just twisted. Select age, max marks from student, group by age. We are getting the maximum marks, not the minimum marks this time. Okay, write a query to display age and the maximum marks scored by each unique age student whose maximum marks is greater than 85 from the table student. Now understand what we are doing here. See, in the earlier till now, whatever problems we have seen, we are just using where and group by, right? So after where we are using group by, correct? Till now we have not used any such particular program where we have used something like this. Now can you see what is happening? So the question is, write a query to display age and maximum marks. So we are displaying age, maximum marks scored by each unique age student whose maximum marks is greater than 85 from the table student. Unique age student, that is why we are using group by, right? So understand that how you have to use the query and write a query. We can't use here where, because maximum marks greater than 85, we are using having clause here. We can't use where maximum marks is greater than 85, right? Because we are using group by also. Okay, let's not get confused. Let me tell you what is happening here. The having clause was added to SQL because the where keyword could not be used with aggregate functions. So if you look here in this particular statement, we are using where clause because there is no aggregate function here, right? There is no aggregate function here. But when it comes to this particular question, we are using here max marks, and if we write where here, then it is wrong, because where cannot be used with aggregate functions like count, sum, max, min, and average. Okay, and that is why we should use having clause. Okay, again I have already told you this, but reiterating that these all clauses, which is where, having, order by, and group by, these all have one sequence which you need to follow. The second thing is that Why there is a group by and having and where clause also? Because there's a difference between all these three. Group by actually groups something, where and having does the same thing, but where cannot be used with aggregate functions, having can be used with aggregate functions. That is why we have having clause. So this is what is the syntax of whole query, starting from select, from, where, group by, having, and then order by. This is the sequence which you need to understand and follow whenever you're writing a query. Next, write a query to display age and the maximum marks scored by all students. Understand the question in a staggered manner. Write a query to display age and the maximum marks scored by all students whose age is greater than 19 and having maximum marks greater than 85 for each age, while displaying the data in ascending order with respect to age. So we know that we will be using here the aggregate function. So select age max marks from student where age is greater than 19. Then group by age, because it is asking for each age. So we know that we have to use group by. Having a max marks greater than 85. Why? Because it is written here maximum marks greater than 85. And we can't use where here because max is a aggregate function. That is why we have used having. And then it should be ordered by age. So this is what we have shown you one example using all our different clauses. So now we are in our next topic, which is nested query, and this is also one of the most important particular topic, because in most of the interviews, if any question has been asked, you need to identify whether you have to use subquery or nested query, or is it just a normal answer, right? And that particular logic, if you know that when to use subquery or when not to use subquery, you understood SQL database. Okay, so let's understand what is this nested query. Obviously, nested query means a query inside a query, but let's understand in an example manner, what does it mean? So we have this table, we remember this particular table from the starting, and so we need USN name and gender of all students whose marks is more than Ravi's marks from the table student. So we need to compare the details with Ravi's marks and then we need to display, okay? So select USN name gender from student where marks is greater than, select marks from student where name equal to Ravi. Now what is this? You can see here inside the bracket, this is one query of select statement, and then we also have one more statement which is a select statement. Now this is what is called as nested query or subqueries. When we have one particular query inside another query, that is what is nothing but subquery or nested query. Now the question arises is which particular query will get solved first. So the inner query should get resolved first, and then whatever will be the result of it, that result will become the solution for the first query as well. So let's divide this particular query into some small chunks and let's understand what we have done. So first of all, this is the table and this is the query which we have written. The inner query says select marks from student where name equal to Ravi. So you have to select the mark from student where name equal to Ravi. So Ravi's marks, if you can see, is 88, right? So what will happen? Marks equal to 88. That means this whole query now gets changes to 88. So now the next query will be select USN name gender from student where marks is greater than 88, correct? We have to actually print the USN name and gender from student where marks is greater than 88. So we have this one and we have this one, correct? And that is what we will get in the result. So we have Kavita, we have, okay, this one also, right? So this is the answer for that particular query, and this is what is called as subquery. Now understand that when you are reading the question, select a query to display USN name and gender of all students whose marks is more than Ravi's marks from the table student, sounds very easy, right? Sounds like I know clause, I know this, that, so I will be able to do it. But this question, nobody was knowing that can be solved using subquery in a very easy way. So that is what interviewer wants from you. The interviewer wants that you should come up with a very good solution of that question with a very good query. Write query to display the USN name of for all the student whose age is same as Arjun's age from the table student. So obviously we'll use the subquery USN name from student where age is equal to select age from student where name is equal to Arjun. I don't think we need an explanation, but still let's see what is happening. Select age from student where name equal to Arjun. Arjun, what is the age? 22. So this will change to 22. Now we have to use the USN name for student where age is equal to 22. So we have two, Arjun and Kavita. That is what it is showing me. Right? A subquery is a query within another SQL query and embedded within the where clause. Subquery is used to return data that will be used in the main query as a condition to further restrict the data to be retrieved. There are some properties of subqueries that should be enclosed within the parenthesis. Subquery can have only one column in the select clause unless multiple columns are in the main query for the subquery to compare its selected columns. An order by cannot be used in a subquery. These are some of the pointers which I'm underlying, and these are very important when you talk about subquery and nested query. Order by cannot be used in a subquery, although the main query can use an order by. So the outer query can have the order by, but the inner query cannot have the order by. Okay. The group by can be used to perform the same function as the order by in a subquery. So don't use order by in the subquery. If you cannot use group by. Subqueries that return more than one row can only be used with multiple value operators such as the in operators. Okay, perfect. Let's move to the next question. Write a query to display name age whose age is equal to the student named Ram and marks is greater than student named Anjana from the table student. Now this particular question is really very frustrating. Why? Because you can see here we need to display name age whose age is equal to student named Ram and marks is greater than student named Anjuna. Let's understand what we have seen. Now there will be two subqueries because we have two such statements. I hope you'll be able to find the two statements. Select name age from student where age is equal to what? Equal to student named Ram. Select age from student where name equal to Ram. And the next is and marks is greater than select marks from student where name is equal to Anjuna. Only one output which is Ram 21. So now let's segregate and let's understand this particular query. What is happening? We have the table here. Select marks from student where name is Anjuna. So select marks from student where name is Anjuna. What is the mark? 75. So this particular statement, this whole statement will result me what? Will result me 75. Right? The next, select age from student where name equal to Ram. So where is the Ram name? I want the age to be 21. So this will become 21. Now the first statement will be that select name age from student where age is equal to 21 and marks is greater than 75. So let's find that. Select name age. So name and age we want from student where age is equal to 21. Age is equal to 21 here and marks is greater than 75, which is only one which is Ram. That is what we are getting. Okay. Now this is what we have done. Let's understand one more example. So this is one table which we have created, student department. Okay. We have department ID, USN, course, city and pin code. How to create this? You already know. You have to create a table and you have to insert these values. I have written some codes here so that you can actually copy it down and put it in your Oracle database. But time being, let's understand what problems or what questions I'm asking here. So write a query to display the department ID of all the students from student department table whose USN in student table is equal to USN in student department. USN in student table is the earlier table. Student department is this table. Okay. So what is the question here? The question is, write a query to display the department ID of all the students from student department table. Now understand, select department ID from student department because that is what I need to see where USN in. Now this is what we have written in the properties. that in subquery we can write in wherever we want. So in subqueries, we have written in select USN from student. Whatever USN is there in the student table, whether it is matching in the student department table, if yes, show it to me. That is what it is saying. So let's understand this particular example in staggered manner. So we have the student table and we have the student department table. We have the student table, this one, and this is our new table, which was student department. What is the first line? The first subquery, select USN from student. So this is the USN from student table. So this all USNs will be recorded. So we have 120, 121, 122, 23, 24, 27, 25 and 26. These are the USNs which we have got from student table. The next is select department ID from student department, where USN in 120, 121. Now what is happening here? Basically all those values are now coming in a bracket within the in method, right? And what happens in operator? In operator says that all these values should be matching. So 120 should match, 121 should match, 122, 123, all these values should match. So from the department ID, which is here, which all USNs are matching? So we have 125, let's cut this, 123, let's cut this, 124, let's cut this, 122, let's cut this, and 121 and 126. So these are all my values, and depending on that, what all department IDs we have? 21, 22, 23, 24, 25 and 26. Correct? If you see here, for 120 and for 127, we have not got any department ID, right? So this is what is the theoretical and practical knowledge on nested query, also known as subquery. So the question is, write a query to display the department ID of all the students from stu department table whose USN in student table is equal to USN in student department, right? So we have to display the department ID for all the students from stu department table whose USN in student table is equal to the USN in student department. So let's say that select department ID from student department student, where student department USN is equal to student USN. Why this is so easy? Why we are not using subquery here? Because here we are only making two things equal, the USN of student department and the USN of student table. Both are the same things. That is why we are not actually needed to use subquery, right? So you have to understand where you have to use subquery, where you have to use the nested queries, and where to not. So in this example, this was easy one. If you again read the questions one by one, you will understand that where to use subquery and where to not. So this was all about nested query. Let's move to the next topic and let's understand what is that. So now we are in our next topic, which is joins in Oracle SQL. And this topic is really very important because joins is such a topic which is asked by every interviewers, right? And from here, many questions will be asked and it will be twisted and it can be very hard, right? So please understand this topic very carefully. Let's start with the introduction of joins. SQL is a structured query language, right? Now, in structured query language, we write a query. When this query will run, we will get some output. Okay, this output will be in table format, right? Now, why this particular query has to be written? Because there will be a question, okay, and we have to solve that question. That question will be solved using this query. Let's say that I have these two tables. Please have a look at these two tables. So we have the imp ID, name, gender, age, salary. The typical table of employee, right? What an employee table should have: an ID, the name, the gender, the age, and salary. Then we have the employee department table. That means this particular table will have the department informations. So we have department ID, employee ID. Now look at this. This employee ID and this employee ID is the primary key. Okay, so in SQL, we have a concept which is nothing but RDBMS, right? Relational Database Management System. So what happens in that? If you have two tables, those two tables should have one common column. Okay. If it is having one common column, then only we can say that those two tables can apply relational database management system. Okay. Now we have those two tables, and both the tables have a one common column, which is imp ID, right? Perfect. Then we have the extra columns, which is department, city, and pin code. Great. I have showed you the tables, right? Now what we have to do? The question is, write a query to display name, gender, age, and marks of all employees whose imp ID in the employee table is equal to the imp ID in the employment department table. Too much long, right? The question is like, I don't understand what is happening here, right? So let's divide this question into two parts. First part is write a query to display name, gender, age, and marks of all employees. This is one part. So what we need to display the name, gender, age, and marks. So that is why I've written here select name, age, gender. Okay. So it's written here marks. Let's say here salary, right? So I need name, age, gender, and salary, okay, of all the employees from employee department. So one particular thing is covered. What is the next thing? The next thing is the condition. See, whose employee ID in the employee table is equal to the employee ID in the employee department table. That means in this table, the employee ID from the employee table should be matching with the employee ID in the employee department table. So let's match it. 206, is it there? Yes, it's there. 208, is it there? No, it's not there. 203, yes, it is there. 201, yes, it is there. 205, yes, it is there. 204, no, it is not there. 207 and 2010, both are also there, right? So now we know that there are 6 items which is matching from both the tables. So these all 6 tables will be shown here. You can see here, these all data are shown here. But what is the condition that we have written? Where employee.imp id, that means from the employee table imp id is equal to employee department imp id. Easy. So we have done the same thing, right? What we have done, we have written that we want name, age, gender, and salary from which table? From employee and employee department, where the employee ID should match from both the tables. And that is what we have written here. Very easy query, right? So we got the output also. But the problem here is, what if I want to show in the result department, city, and pin code also? Till now, what we are doing, we are only showing name, age, gender, and salary. But now I want to show the data or the column of another table also. Then what you have to do? Then you have to use the join keyword. How we can do that? Let's see. Now we'll understand what is join. So join is a means for combining fields from two tables by using values common to each. So we have two tables and we have to join these two tables using the common column which is there. So we have one common column which is employee ID in both the tables. We can join it. There are different types of joins: inner, left, right, full, natural, and cross. We are going to discuss these all right away. Have a look here. Let's understand what is this. Have a look. Table 1. Let's consider that this is the orange color table 1. Then we have the table 2, which is a green color. Now these blue color things are nothing but the common data. Okay, these are the common data. So when I talk about inner join, it means that it will return all rows from both the tables where there is at least one match in both the table. So all the common details will be coming in the inner join. All the common details. In Hindi, if I speak, then जो भी common data है, वो सारे data इन दोनों tables से fetch होगा, right? So from both the tables, whatever the common data is there, that will be coming in inner join. When you talk about left join, in left join, the data of the left table, complete data of the left table plus the common one. Can you see the orange color and the blue color? So all the data from the left table, but only the common ones from the right one. See, return all rows from the left table and the matched rows from the right table. Okay, if you have understood this, then right join will be very easy to understand. But if you have not understood the left join, don't worry. We will go to left join and we will see some examples and we'll understand what is happening there. Okay, so don't worry about that. Right join, simple. The same thing, opposite to left join. Here, the right table, all the data will be coming, and only the common data will be coming from the another table, right? So you can see the portion which I'm engaging here, the blue one and the green one, right? So basically, all the data from the right table, but only the common details, only the common data from the other table. Now let's talk about full join. Full join is very easy. It's nothing but sab kuch. Everything will be coming in the table, in the resulting table. So the left table also complete, the right table also complete, and the common details also complete. Everything will be coming. So you can see return all rows when there is a match in one of the tables, right? This is what is your different types of joins. The rest of the joins, which is nothing but natural, cross, self, those are really very easy. If you understand these, then this is good to go. Now let's move to the inner join. Let's understand with the question. You remember the two tables which I showed you, employee and employee department? Let's understand that. So when it comes to inner join or join, right, we can use both the terms. We can use join also, we can use inner join also. Now have a look. Write a query to display all the details from employee and employee department. So can I say that this is the first part of the question? So let's solve that. Write a query to display means we want all the details, everything, every column. We want every column from employee and employee department, where the value of employee ID in employee is equal to the value of employee ID in employee department. So will I write the query like this? Right? Select star. Why star? Because all details we want. From which all tables I want? From employee and from employee department. On which condition basic I want? I want the condition basis to be employee.employee ID equal to employee department.employee ID. Great, my query is done and I'm getting all the necessary columns. Can you see? Employee ID, name, gender, age, salary. These all 5 columns were there in employee table. Then we have department ID, employee ID, department, city, pin code. These 5 were from the employee department table, right? Now you can observe that everything is coming here. So that means we have joined the two table. But one more thing to focus here, guys. Employee ID is coming twice, right? So whenever you are using inner join, the common column from the two tables will come in twice. That means duplicate column will come. So you can see employee ID is coming twice. The data is also same. Only the common detail is coming. Do you remember this particular drawing? What is inner join? Only the common detail. You see, only the common detail is coming. Correct? Okay, we will talk about it later that how can we remove this duplicate column? How can we remove it? We will talk about it later. Don't worry. Let's come here. Can you see this inner join? Okay, can you see I've written here inner join? Now I'm changing the screenshot. Okay, let's have a look. So, on a count of 3, I will remove the screenshot. 1, 2, 3. Can you see? Now I've not written inner join, I've written join, right? And the output is same. The output is not changed. So either you use join or inner join, it doesn't matter. It works the same, okay? It just joins and gives you the common columns, the column details, the common data. Now here, see, again, I have changed the screenshot. Can you see? Employee E1. So I've given an alias name. See, employee department is such a long name, right? Such a big name. I can't use it every time. So I've given a alias name to it. Like you have a home name and you have a official name, right? So we have done like that. So employee is the official name, but even is the home name. Like that, E2, right? So we are using E1.imp ID, E2.imp ID. Now we are not writing employee.imp ID, imp department.imp ID. No, we are directly using the alias name. This is called as alias. Okay, that means giving another name to the table. Now we are using inner join. We can also use join. I hope you understood the concept of join or inner join, right? Now the next topic, which is left join. So left join, left outer join. Now we have a write a query to display all the details from employee and common details from employee department by using left join. It says that we have to use the left join. Now understand the question. Write a query to display all the details from employee. This is one part. That means I want every details from employee. But we want only the common details from employee department, not everything. So what is the situation here? The situation is that from one table I want everything, but from other table I want only the common details. Can't we use left join? So in the left join, what will happen? See, I have written the left join here, right? And the table which I have written on the left hand side is which one? Employee. So from employee, all the details will come, but from the employee department, only the common details will come. Easy? What will happen if you will swap that? Swap in the sense, what will happen if you will write here employee department, left join employee? Then employee department's all detail will come and employee only common details will come. That I will show you later on. Right now, let's stick to this. Perfect. So now what we have to do? We have to see how it is coming, how this thing is working, right? So if you see, remember we have 8 data in both of the tables, right? Employee table, we have 8 data, and in employee department also we have 8 data. If you see here, it should show me all the details from employee. Can you see? All the 8 data is shown here. But from employee department, can you see all the data? No, only 6 data is coming. Why only 6 data is coming? Because the 2 data which we have is not common. See, 204 and 208. Do we have 208 and 204 here in this employee department table? We don't have it, right? That means 2 of the data are not common. 2 of the data details are not given in employee department. And that is the reason it is not showing in our left join table also, right? That is why these are blank. Can you see these are blank? Why? Because the data is not common in the right hand side table. Okay. Now I have written here left join. So you can see left outer join. We can write that also. You write left join, left outer join, doesn't matter. Then we have the alias name E1 and E2. You can see that. So you have taken that, you have used left join. Left outer join also we can use and we'll do the same thing. Right? Easy. If you have understood left join now, I hope you guys have understood. Let's move to the right join till then and let's understand what is this. Right join means that right table everything will come, but the left table only common details will come. So have a look what I've written. Write a query to display common details from employee. Now I need only common details from employee, but all the details from employee department. Right? Now query samajh mein aa gaya hoga. You will get the query in your mind itself, right? That what it will be. Select star from employee. Right join employee department. That means the table which is in the right, I want all the details from there, but the table which is in the left, I want only the common details from that. And you can see from the employee table, only the common detail is coming, only 6 data. When we were using left join, all the details were coming, but now it's opposite. It's ulta, right? See from the employee department table, I'm getting every data, all the 8 data. Why there are blank spaces? Why there are null values? Because there are 2 data which is not matching, which is not common. So that is why I'm getting a blank space here. Correct? This is what is your right join. Can you give example and how it works in condition clauses? Just surely I will try to code one particular code where I can show you that, how you can put a condition also. Let me do that. I'll go to my Oracle and here I have the table. Let me show you how it looks. So select star from, let's say I'm writing employee. Okay, I'm writing employee and I'm putting right join, right? And I'm putting employee department. Guys, please look at this particular query which I'm writing right away. This is really very important, as one person has asked me that please provide a condition or something, right? Right. So let's do that. Right join employee department, and here what we will do is, okay, so we have the condition. Now we have to write the condition. So have a look what we are writing, on employee, right? So that's our condition. So let's write on employee dot imp id equal to imp department and then the imp id. This is what is my condition. If I run this, what will happen? I'll get the same data. You can see. 1 second. There is a employee right join on employee dot imp id. Okay, so here I have not used the dot. Yeah, so you can see you are getting the table, the same table which I have added in the screenshot, right? The same thing. But now, suppose I want the, from this data, I want only those particular columns which is having salary greater than 4 lakhs or 5 lakhs. So what I should write? Where employee, why I'm writing employee? Because salary column kahan pe hai? Salary column is on employee table. So I'm writing employee dot salary equal to, let's say there are most of the things, most of the salaries which are greater than 5 lakhs. So let's write 5 lakhs, okay, and run this. Am I getting all the data which is having salary greater than 5 lakhs? Yes, I am getting, you can see, right? So this is how you can use the condition clause, which is where, right? And you can get the output. Perfect. Let's move to the next topic, which is nothing but full join. So here what I have told you, it's very easy, right? Everything will come here, everything. So let's do it and show it to you in this particular example itself. I want to show you one more thing, guys. Have a look. If I hit enter and if I write here, select star from employee, let's write full join and let's say imp department. Okay. Now you can see there are two queries which I've written here, right? Now if I run this, what will happen? You can see invalid SQL statement, right? Why it is invalid? Because I've written two queries in the same box. What if I'm selecting one of them and then I'm running? Okay, so now it is saying missing keyword because I've not written the conditions. I have to write the condition as well. Let me write the condition. Employee ID is equal to imp department dot imp ID. Right? Let's run this. Let's do it one by one. Let's run this. Okay. So I am getting the whole table, if you can see. What is this? The full join, right? Now, if you can see from the employee table also, I'm getting 8 data. And from employee department table also, I'm getting 8 data, if you can see. 205, 203, 206, 207 till 208. 8 data. And then from the department also, you can see I have 8 data. If you want to see it from here also. 6 here and then 2 here. So we have the total 8 data from employee table. And we have all the 8 data from the department also. Right? So this is what is full join. Now, wherever the columns are not matching or wherever the data is not matching, there we have the null values. Can you see? This is what is your full join. Try to do this in your own systems, guys. If you want, try to do it and practice more in your own Oracle database engine. You'll not be able to gain confidence in this. Okay. So try to do that. Now let's see what we have done. Full join. Can we write full outer join? Yes, we can. Can we use alias? We can. Can we use alias with full outer join? Yes, we can. Anything is fine. You just have to write the query, correct? Okay, so we have seen a lot of our different types of joins, but still there are some of the joins which is left, right? So let's talk about that. Mainly where we use this query. I'll tell you where we use this query. See, basically every organization, every bigger organization or any business, right, will have database. Okay, let's imagine, let's take an example of Mintra.com, right? In Mintra, you guys will shop, right? What we guys do, we guys only shop, but we don't consider or think about what's happening in the back end. Basically, our all details, our all data is getting recorded somewhere, and all those data are recorded in the table format like this. Okay. Now, suppose Mintra.com wants to know that which particular customer is very frequent in my app, who is very frequent in my app. Like he has opened the Mintra app every single day. So what he can do, he can write a query where he can write select a star from Mintra table where the opening of the app is very high, right? The amount of opening the app is really very high. So all the list of names, all the details of those names will come up who have always opened the Mintra app. So they will get to know that these are our regular customers. We have to give something to them, or we can give some offers to them so that they can again shop, right? So these are the queries which actually our organization or most of the companies uses to play with the data, to manipulate with the data. Okay. Suppose they want to find some of the people who are not at all using Mintra app from 3 years, then they can remove their account. They can remove their account from their database. Correct? So those are the things. Now here we are coming with the new topic, which is natural join. Now understand what is natural join, right? Because in the diagrammatic representation, I did not tell you what is it, right? So let's understand that. Natural join is a join operation that creates an implicit join clause for you based on the common columns in the two table being joined. So there are two tables, okay? There are two tables. One of the column is common, right? Now, what is happening in inner join? Basically, whatever common column is there, it's coming duplicate, right? It's coming twice. Remember, I showed you that imp id column was coming twice in the resulting table, right? But here in natural join, it doesn't happen so. So if a question is there, right, equal to display all the details, that means they want all the details. Where the value of imp id in employee is equal to value of imp id in employee department, then we have to use natural join, and we use natural join. Then what happens? I'm getting only one employee ID column. Can you see? There is no other employee ID column. So duplication of column is not happening here. So inner join and natural join is somewhat similar, but natural join is better. Why? Because here it doesn't duplicate any other column. It actually gives me only one column and with all the other data. But have a look, right? This table is looking quite amazing because we don't have any errors in this. We don't have any duplicate row. We don't have any duplicate column. This table is looking perfect. This is nothing but your natural join. Okay, one more thing. If we can use natural join as an inner join, can we use natural join as a left join? Certainly we can. Have a look. Natural left join. So whichever table is there in the left hand side, its all data will be presented. See, all the 8 data are present, but from the employee department table, only the common details are present, right? This is what is your natural left join. Natural right join, the same thing will happen. So we have understood one thing from here, that duplication of the common column will not happen. The second thing which we have understood, if you have noticed, guys, if you have noticed, we are not writing the condition on employee.impid equal to employee department.impid, nothing. We are not writing the condition itself. This is the use of natural join. This is the benefit of using natural join. So these are the two major things, major benefit of natural join, right? So natural right join, same thing, and natural full join. Can you see? Everything is coming. Every data is coming. 8 data from employee table and 8 data from employee department. But employee ID is only one column, right? So I hope you have understood natural join. Now we are jumping into the cross join. Let's see what is cross join. This is really very fun because here we multiply everything to anything. Let me tell you what is this. Suppose if I have a table, okay, and I have one row. Suppose I have 3 rows. 1, 2, 3, 4 rows, okay? And I have another table, and here also I have 4 rows. 1, 2, 3, and 4. What will happen in cross join? It will cross it. What is cross? Something like matrix multiplication. If you are from the science stream, you must be knowing matrix multiplication. What happens? This one row will get multiplied with every other row of the table. Every other row of the other table. Then after that, the second row from this table will get multiplied with every other row of the other table. So what are we doing here? We are multiplying every row of one table from every other row of other table, right? Have a look. Cartesian join or cross join. This is what we also call it as Cartesian join or cross join. Returns the Cartesian product of the sets of record from the two or more joined tables. So if I have these two tables, what will happen? The very first row will get multiplied with the very first row of the second table, second row of the second table, third row of the second table, and it will go on. So if the first row is multiplied with the first, that means 8 rows will come. 1 is the first one, then second, third, fourth, fifth, sixth, seventh, eighth. This will also give me 8. This will also give me 8. This, and this. If you add these all, those many rows I am getting into my resulting table. Those many rows I will get into my resulting table, and will look something like this. So I have 8 data from Aman, 8 data from Tanisha, 8 data from Harpreet, which I have not given because the table was really big. This is what is your cross join. Where do we need it? Where do we use this? Cross join can be used in any table, any database. Why? See, if you want to understand that one particular person is living in which area and what are the different cases, like suppose 206 Aman, male, 24, who is earning 3,50,000. His department ID can be 21, can be 23, can be 22, can be these all. So he is the possibility of working on all these departments. Like that, if you want to cross, you can do it. Okay. This example certainly doesn't look good when you talk about cross join, but yes, we have certain different examples which will explain why do we use cross join. Okay. The next one is self join, and this is the last one. So let's understand how this self join actually works. Now, the SQL self join is used to join table to itself as if the table were two tables. Now, we have seen a lot of joins. We have seen inner join, left join, outer join, right join, natural join, cross join, and you've seen a lot of variations in these joins, right? Like if you talk about inner join, it actually tells me the common data, right? And when you talk about cross join, it actually cross joins both the tables and gives me a very detailed view of all the data. But when you talk about self join, there are no two tables. There's only one table which is actually joined with itself. Now you will ask me, how does that happen, right? Because if you don't have two tables, then there's no meaning of joining anything, right? Now how does that happen? Now, to join a table itself means that each row of the table is combined with itself and with every other row of the table. Okay. Now to understand this, we have to clearly understand the cross join because it is much more similar than cross join. Okay. Now what is happening? The table itself is getting divided into two parts, right? So let's say that I have a table which is a student table, and what we will do is we will create student table, and this particular self join, whenever we will use, the student table will be recreated into two tables, student A, student B, and then these two tables will be joined. Okay, now this division we are not doing. This division is happening because of self join itself. So if you look here, we are using only one table, which is table 1 in the syntax, but we have clearly said that it should be divided into two tables, table 1A, table 1B. And then from A table 1, we want the column name, and from B table 1, we want the column name, the same column name. And the condition is that the common field should be matching. So if you look here, we have this particular table, imp ID, name, gender, age, and salary. Just have a look clearly what are the things present in this table, because we are going to use the self join to this table, right? So self joining means that whatever code we are writing it in a way that two tables are created. So we have an employee table. Employee E1 is one of the table and employee E2 is second table. From employee 1, we want employee ID and salary, but from employee 2, we only want the name, where employee 1 salary is less than employee 2 salary. Now you don't know this employee table will get divided how and from where. Let's say that this is from E1, this is from E1, this is from E2, this is from E2, this is from E2, this is from E1, this is from E2, and this is from E1. Some random selection will happen, and randomly these all tables will be divided. What I have written is just an example. Now in E2 we have this and this data and this data. And what is it saying? That we want only the names from this table. So we want the names Harpreet, Ram, Vishal and Rohan. And from employee 1, what all things we need? We need the ID, right? So we need these IDs and we need the salary. So this and this, right? So these are the things which we need or which we need to display in our resultant table, right? But the condition is E1 salary should be greater than E2 dot salary. So if you look here, E1 salary, which is 3,50,000. The next is 4,60,000. These all should be greater than the E2 salary, which is 8,90,000, 3,58,000, 5,60,000 and 7 lakh. Right? Now what are those data? So those data, if you look here, see 3,50,000, if you just see the salary part, right? The tick ones are E2 and the underlined ones are E1. Now you have to make sure that which one's E1 is greater than E2. So 4,60,000, if you look here, now to do this, it's a very tedious task, right? We can't do this manually. So let's see what we have come up with. Now, if you look here, I have created one imp ID salary for employee 1 and the only name from employee 2, right? Now, all these rows, all the rows from each of the tables will get multiplied with each of the rows from the another table. And this will give me an output of something like this. So we have 206, Tanisha, and then 3,50,000. 206, Harpreet, then 3,50,000. Similarly for all the things. Now we have to understand that E1 salary is greater than E2 salary, where and all it is there, right? So that is how you actually do the self join. Now we are in our next topic, which is select from multiple tables without join. Now this is very easy. We don't have to use join topic. Without join, we have to select from multiple tables. This we have already seen, but let's see it once more. Write a query to display all the details of employees whose employee ID in the employee table is equal to the employee ID in the employee department table without using joins. Imp ID in the employee table and imp ID in the employee department table without using joins. Now, if you talk about this particular topic, we have already seen one of the statement where we are not using joins, which is this. Select star from employee E1, imp department E2, where E1.impid is equal to E2.impid. We are not using joins, but still we are getting the all joined tables resultant table, right? Now, this is one thing, join multiple tables with conditions. Now, with conditions also we have seen one example, but here we will see one more example and try to understand that how we can join multiple tables with condition. So write a query to display salary, employee ID from employee table. This is one part. And department city from employee department table. This is another part. Whose employee ID in the employee table is equal to the employee ID in the employee department table and salary is greater than 4 lakh. So this is one of the condition now that salary should be greater than 4 lakh. So if you look at the query, select E1.salary, E1.impid, E2.department, E2.city from employee 1, inner join employee department E2 on employee E1.impid equal to E2.impid where E1.salary is greater than 4 lakh. This is what I wanted and we are using a condition. So we have only these details where the employee 1 salary is greater than 4 lakhs, right? So you can use a condition like this by using a where clause. Now the very important topic and the last topic in joins, which is how to join 3 tables in SQL. So how you can actually join 3 tables in SQL. Let's first consider 3 tables. We have employee, employee department and department. Very small table for this particular example. So we have an employee where we have employee ID, employee first name, employee last name. We have employee department where we have employee ID and department ID. We have department where we have employee ID, department name, and department head ID. Now, if you see, employee ID is common in all the tables, right? That means these are relational. And if you clearly look here, we have the employee first name and last name in the employee table. Department ID, which is again a primary key for employee department, and department name and department head ID is something which is in department table, right? Now we have to join these three tables. Can we join? First of all, the question is, can we join three tables? Yes, we can join three tables, but the query should be written perfectly. Now, if you look here, step by step, I'm going to show you what all queries we have written and how we are joining. So first we have written select employee.employee first name, comma, employee.employee last name from employee. Very easy. What you will get? You will get all the employee first name and employee last name from the employee table. That is what I'm getting, right? Perfect. These are the just three tables which I have shown you here to show you that what are the content in the table so that you don't get confused. Next, now what I'm writing, select employee.employee first name, employee.employee last name from employee, join employee department on employee.empid equal to employee department.empid. Now we are using the join keyword with employee department. That means this one and this table is getting joined together. On what basis? On employee ID basis. But we are only displaying first name and last name. Make sure about that. So we are only displaying first name and last name, but with imp department table. So 2 1 and 4 2s and 1 3s. That is why these data is also getting repeated. So till now we have joined two tables. Let's see what is next. Now select employee.employee first name, employee.employee last name from employee, join employee department. These all things we have done. Next I'm adding department.department name. Now I want the department.department name, this part also in my result with first name and last name. So department name, first name and last name, these three things will be shown on the basis of join department employee ID.employee ID. So this is what is the result. On the basis of these three unique IDs or primary key, we are getting this particular result where we have the department name, first name and last name. And this is how you actually join the three tables. So this was all about joins. Let's move to the next topic and let's see what is there in the next topic. So now let's understand and clear out what are the different SQL commands in Oracle database and what do they do, and all the different types of SQL commands, what are their works individually, right? So first of all, let's see what all typical SQL commands do we have. So if you can see here, we have DDL, DML, DCL and TCL. Now these are some of the four main commands which we actually use. DDL is data definition, DML is data manipulation, DCL is data control, and TCL is transaction control language. Okay. Now these all are different in work. Okay. But we'll try to see all of these in a separate and individual basis. We'll see all these commands, individual commands one by one by example, and we'll try to understand how these all are different from each other. So let's first start with DDL and let's see how this create, drop, alter and truncate works. Now, before jumping into that, let me tell you that this is data definition language. That means it defines the data, right? So when you want to create a particular table, that is where you are defining the data. Dropping the table, that means when you are deleting, that is defining the data. Alter means when you want to change the data, that is definition. Truncate, again delete, so that is also definition. Now you will try to see here that drop, delete, truncate are three of the commands which is looking like a similar command, right? Drop, delete and truncate, all of them are nothing but deleting. But what is it deleting? That what we have to see. So let's start with DDL and let's understand what is data definition. So how to define data? DDL changes the structure of the table, like creating a table, deleting a table, altering a table. These are nothing but changing the definition of the table. All the command of DDL are auto committed Auto committed means that once you're writing that particular program, it's auto committed. It can't be changed. Okay, that means it permanently save all the changes in the database. Okay, the first one is create. So it creates a new table in the database. This particular command, no need to again revise because we already know how to do this. We are using create table name, table name, and then the column name, data types, whatever you want to put. This is what is the syntax of create table. We already know about this. So one question based on this: write a query to create the table course with columns such as course ID, course name, course duration, course faculty. This is how you will write the create table command for this particular question. And I don't need to explain it because we already know this. Let's move to the next one, which is drop. Now understand what drop does. It is used to delete both the structure and the record stored in the table. That means if you've designed a table, there will be a structure, right? Like 2 rows or 3 columns or 4 columns. There will be a structure. And another thing which comes here is data. So inside this table, you'll have data. Now when you're doing drop means dropping that particular table. The structure also, the record also, everything. So when you're dropping the table, you're actually deleting everything of that particular table. So write a query to delete the structure and record of the table. Then you have to use drop table course. So once you do that, after dropping the table course, if you try to find the content of the course, it will say table or view does not exist. Nothing exists. Even the structure is not there, right? And once you try to find out the description of that particular course table, now what is happening is object to be described could not be found because there is no table as such. There is no structure also. So object to describe is could not be found. Okay. Now let's move to the next one, which is what happens if you try to drop dual table. So this is one of the question. Dual table is a default table, right? And if you want to drop it, then what will happen? So if you want to drop the table dual, table or view does not exist. See, dual table is a default table which is provided by a Oracle, right? Now, it is not a particular permanent table. It's just a table from which you can play or which you can practice. So you can't drop dual table. Now let's come back to the alter. What is alter? It is used to alter the structure of the database. This change could be either to modify the characteristics of an existing attribute or probably to add a new attribute. So if you want to add something or to modify something, we use this. Now, these three are very important. Please understand it one by one. To add a new column in the table. Let's say that I have 3 columns, but I want to add one more column. It can happen, right? That you have name, age, and gender. But later on you decided that we should have city also. Then alter table, table name, add column name, and then column definition. This is how you will write a one particular syntax or an query to add a new column to your table. To modify existing column in the table, that means if you have a column already and you want to modify that, then alter table, table name, modify the column name which you already have, what particular change you want there. To rename existing column name in the table, if you want to rename the existing column name, let's say that my column name is age and I want to permanently change it to years old, not an alias. Do not get confused. Alias is a temporary name change. This which you are doing is renaming. That means permanently changing the name. So rename column old column name. You can see here old column name to new column name. Okay. Let's do some questions. Write a query to add a new column in the table course with columns such as course fees. So I want to add a new column. Alter table course. Course is the table name. Add course fees. Course fees is my new column name with this description. Right? Next question. Now if you see the description of the course table, you can find course fees here, right? Okay. Now let's see next question. Write a query to modify the column course fees in the table course with size as 20. Now if you look here, the size here is 30, right? And now this particular column is already there in the table. Now what I want to do is, I want to edit this particular column. I want to alter something in this column. So I want to modify the column and I want to write the precision to be 20, not 30. So alter table course modify course fees number 20. Instead of 30, I've written 20. And you can see that it is not changed to 20, right? Next one, write a query to rename the column name course faculty in the table course with course trainer. So I want to replace the name course faculty course trainer. So alter table course, rename column course faculty, which is the old name, to course trainer, right? So table is altered and you can see here that course faculty is not changed to course trainer, right? So this is what is altering. Let's move to the next one. Write a query to rename the table name course to course description. Now I want to actually rename the table itself. So table name is course, but I want it to be course description. There are two ways: alter table old table name, rename to new table name, or otherwise what you can do, just write rename old table name to new table name. So we are just writing alter table course, rename to course description, and that is done. Or you can do rename course to course description, right? Why I'm adding these screenshots here to show you, because this is the proof that it works, right? So don't think that I'm not going to the Oracle and I'm showing you, because it will take time. That is why I've added directly the description or the screenshots, right? So now when you see the description of code description, you can find here that the table name has been changed permanently. Okay. So now let's move to the next question, which is write a query to delete one of the column from the course table. So I want to only delete one of the column. Alter table course, course is the table name, drop column course name. If you want to only drop one of the column, then drop column course name. Course name is the column name. This is done, and you can see here that column name is not there, right? Okay. The next one, the last particular command is truncate. Let's see how is it different from drop. It is used to delete all the rows from the table and free the space containing the table. It is used to delete all the rows from the table and free the space containing the table. But for structure, there is nothing written here. So if I want to write a query to delete all the rows and not the structure, then we have to use truncate. So no data is found, but it is not saying the table doesn't exist. It is just saying that data is not there. Now, once I want to see the description of this particular table, what is happening? You can see here that description, when I'm truncating, it is not deleting the structure. The structure is as it is. It's just that the data is gone. Okay. So truncate will just delete the data or the rows or the values, but not the structure of the table. Whereas drop actually drops everything. Okay. Now we are done with the DDL. So now we are jumping into the DML, which is data manipulation language. That means how to manipulate the data. That means how we can actually insert something inside or delete something or update something inside the values, not to the table. Now, DML commands are used to modify the database. It is responsible for all form of changes in the database. The command of DML is not auto-committed. Remember that DDL is auto-committed, but this is not auto-committed. That means it can't permanently save all the changes in the database. It can be rolled back. It can be done undo. Okay, so insert. The insert statement is SQL query. We already know what does it do, right? So insert actually inserts the values inside the table. We already know about that. Write a query to insert all the values to all the columns of the table course. We do this and all the values will be inserted. It will look something like this, right? Okay, the next one. This command is used to update or modify the value of a column in the table. So once you want to update or modify the value of a column, then we use update. How do we do it? Update table name set column name equal to value 1, column name equal to value whatever columns you want to change. If you have any condition, you can put the where condition as well. So write a query to update the value of the course fees from 6,000 to 10,000, where course faculty is Ritvik in the table course. So we have the course fees here and we want that 6,000 should be changed to 10,000 wherever the course trainer is Ritvik. So here and here, right? So this is what I want. How to update this? Update course, which is the table name, set course fees equal to 10,000 where course trainer is equal to Ritvik. Very easy. This is how you can do the updation. So select star from course. Now you can see the Ritvik course student is having 10,000 course fees, right? Now delete. So it is used to remove one or more row from a table. Again, drops everything, truncate, just delete the rows or the values from the table but keeps the structure. Delete is used to remove one or more row from a table. That means one data or one of the sale data, only that will be removed. Which one you want to remove, that will be removed. Write a query to delete all the rows from the table course where the course is taken by Ritvik. So I want to delete only those course details which is taken by Ritvik. So delete from course where course name is equal to Ritvik. I hope you understood the exact meaning of these three things: drop, truncate and delete. So do not get confused because this is one of the very important question asked in the interview. So you can see Ritvik information is now gone. Next, what happens when no condition is specified in delete statement? Example, delete from course. So what happens when no condition is specified in delete statement? Let's say I'm just putting delete from course. So everything will be deleted. That means every data will be deleted. Okay. So if I write select staff from course, it says no data found. And if I want to see the description of the course, it is having the structure. The data is just gone. It's having the structure. That means if I write delete without the condition, it works like truncate. Isn't it? Truncate also does the same thing, right? It just keeps the structure and deletes all the rows. So if you're using delete command in DML and not using any condition, it works like truncate itself, right? That brings us to our third command, which is DCL, which is data control language. So how to control data, right? Now, how to control data is nothing but there are two things. Either we can control it by giving permission or taking permission, right? So there are two commands, which is grant or revoke. Now, if you see here, DCL commands are used to grant and take back authority from any database user. So either I can give privilege or I can take the privilege. That is what we do in DCL. Now, granted is used to give user access privileges to a database. How do we do that? Grant privilege name on object name to whomsoever you want to give. Now, what is this privilege name, public and role name? Privilege name is the access right or privilege granted to the user. Object name is the name of the database, object like table. And username is the name of the user to whom an access right is being granted. I'll tell you how to do this. Let's understand with an example. So once you download Oracle, you'll be able to find SQL command line itself. Let me show you. So if you go to your start and if you scroll down, you'll be able to find Oracle folder, and inside that you'll be able to find run SQL command line. Once you open that, this particular SQL plus command line will open and you can start writing your grant revoke commands, right? Now let's see what happens here. I'm not going to show you here, but in the PPT everything is given. So let's move back. So here what you can see is what we have done here. We are trying to do the connection. So we use con is used to do the connection. When we have given the username, which is system, and password I have given root, it's connected. And then what I'm doing is create user student. So I have created another user, which is named as student. And I want to give the password also. How do you give the password? You give it identified by a password. So password also is the student for me, and the username is also student. Thus, user is created, right? Now, once the user is created, what I can do, I can connect to student username and not system. So what I can do here, you can see con username student, password I have given is student. Once I hit enter, it says user student lacks create session privilege, log on denied. So what is happening? It is throwing error because system user has not provided any privilege to the new user student. So from where I created this student user? From system, right? So system has to give privilege to student so that this new student user can be created. But we have not done that, right? So what you have to do? We have to grant all privilege to student. Can you see here? Grant all privileges to student. Once I do that, then what will happen? You will be able to create a user and you'll be able to use that. So we have to reconnect to the user system to grant privileges. We just disconnected and we again created it. You can see con system, we created it and grant all privileges to student. Grant succeeded. Earlier it was not succeeded because we were out of the system user authority. Okay, so users using system user to grant all privileges to a new user student, and that is done. Now you can see what we have done. So now we are trying to access con connections, student user connection. It's connected and we are creating a table stud with two of the things, ID and name. ID being a number and name being a varchar. That means now if I go back to my Oracle database, the port number 8080, and if I try to log into student database, I will be able to find this stud table. Let's see. So when I go back, I can find here in my student particular database, you can see username student, and I have the stud table here with two of the things, ID and name. So this is how from system user we have grant privileges to student user, and thus you have created the things or the tables. So checking through database homepage, right? Okay. Now this was all about grant, but what is revoke? Revoke is taking back. So it's just like grant, but it's the opposite. So revoke will take all the accessibility from your connection. So now what we will do here is, you can see I've connected to system and I'm revoking all privileges from student. Okay. So revoke succeeded. What I have done here basically is I have taken the privilege from student. Now it won't be able to create anything. So you can see here. Now if I try to log in with a student, user student lacks create session privilege, login denied. So when trying to access new user student, it throws an error because I have revoked all the privileges. How to list users in the Oracle database? What all users you have created? How can you see all those users? See, by default, Oracle also gives us the all the list of users, right? And what you have created will also be shown. So to list all users that are visible to the current user, that means if you are in system user, then for system user, which all users are visible? To see that, you have to use select star from all users. Okay. And if you want to see it in an order, ascending order or descending order, then you can use order by created. Okay. Now list all users in the Oracle database. No matter what user you are using, you are in sys or system or student, select star from DBA users will give you all the users which is getting created in the Oracle database of yours Oracle database. Again, you can sort it by order by. Show the information of the current user. You want to see only the information of the current user, like which is system, then you can write select star from user underscore users from these all commands. Now let me show you some of the screenshots which we have covered. So you can see here, select star from user users, right? So you can see user users, as I told, that will show you the current system detail. So we are in our system, it is showing me the current system detail. Select star from user users. When you'll be in student, it will show you the student details. Correct? So this is what is my DCL, which is data control. Now let's move to the TCL, which is transaction control. Now in transaction control can only use with DML commands like insert, delete and update. What are these transaction control? Let's understand that. It is used to control transactional processing. Okay. Now what is this transaction processing? Let's understand by understanding two of the keywords which are commit and rollback. Now understand, when we were learning about DML commands, we understood that insert, delete and update, these are all non-auto commit things. That means permanently these are not getting saved. Okay. When you talk about DDL, these are all permanently getting saved because these are auto committed commands. DML are not auto committed, and that is why TCL can only be applied to DML commands, because here what happens is we can commit or roll back using the commands. So we have a command to commit and roll back. DDL, we don't need it. DML, we need it. So in DML we use commit. Commit command is used to save all the transaction to the database. So if I have this particular query, which is delete from department where department name equal to marketing, right? So one row is deleted. but I committed till now. Right now I have committed it. Committed means it's permanently done. So statement is processed. Correct? Now if I do select star from department, I won't be able to find that data. Okay? The next, rollback. Rollback command is used to undo transactions that have not already been saved to the database. So we can actually roll back, we can undo. So let's see. Delete from department where department name equal to admin. So you want to delete from the department table where department name is equal to admin. So 2 rows are deleted, right? We are rollbacking. That means we are undoing it. Now you can see here that we have the admin details. It's not deleted. So it's rollback, it's undo, correct? That is what is your TCL, which is also nothing but commit and rollback. So you can do this as well. You can see here, delete from department where department name equal to admin, commit and then roll back. Now understand, once you have committed, you can't roll back. If you see, admin is not showing here again, right? Now what is save point? Commit, rollback we have understood, but what is save point? Understand it in a very easy manner. Save points are like checkpoints. So in a marathon, you have some checkpoints, right? You reach one checkpoint and then you go for another checkpoint. Same thing happens here. So we design the checkpoints that once this transaction is completed, put a save point there, put a checkpoint. Then move to the next, some other queries and then put a checkpoint. So if I have to actually see the table of student 1, I have some of these things. ID, name, gender, age and pass out year. ID is 1, name is Ritvik, gender is male, age is 26, pass out year is 2015. Correct? Like that we have some more data, right? Now, what we are doing here is update student 1, set age equal to 29 where name equal to Ritvik. So this is updated and I have created a save point here. That means one flag I have raised here, okay, that I can come back sometime later and I can roll back this save point. That is upon me. I can do that. So update student 1, again I'm doing that, age 30 where name is equal to Rohan. Again I have save pointed it. Right? So I have again raised a flag here. Why I'm raising a flag? Because I am not sure whether the age is 30 of Rohan or whether the age is 29 of Ritvik. It can be something else and I can come back and I can roll back these particular statements. So those are save points. Okay. Now you can see here that this has been changed, right? Okay. Now you can see roll back to save point 1. Now I am roll backing to save point SP1. So you can see I am roll backing to SP1. That means SP2 will be removed, SP1 will be kept. So you can see Ritvik is 29 only, but Rohan 30 is now roll back to 28. If I would have written roll back, complete roll back, then it would have been changed Ritvik's age also. Right? So those were all the SQL commands, which is DDL, DCL, DML and TCL. I hope easily you have understood what are these things. So now we are in our last topic, which is database objects. Let's understand what are these and why do we use it in SQL language or Oracle database. So first of all, database object is any defined object in a database. It is actually created to make our life easier when we are writing a query. Okay. So it can be creating a temporary table or it can be creating a sequence of numbers. It can be creating a particular index for one particular table, can be anything such like that. Now it is used to store or difference data. Anything which is make from create command is known as database objects. So anything which you create using create command is known as database object. It can be a table also because while creating a table we use create command. So it can be a table, it can be a view, it can be sequence, index or synonym. Now what are these? Let's understand. Table, basic unit of storage, we use it to store data. It is composed of rows and columns. We have already seen a lot of times. So table is one of the object. View is logically represent subsets of data from one or more tables. So let's say that you have two tables, student and student department. Now from these both tables, you want to take some data and you want to create a new temporary data for your own purpose. Okay, so you want to take some data from student, you want to take some data from student department, and you want to combine together and create another kind of table which is called as view. Okay, and you give a separate name for that view, but that data or that table is not permanent, it's temporary. Sequences which generates primary key values like 1 2 3 4 5 6 7 8, or starting from 10 11 12 13, right? That is sequence. Index, it improves the performance of some queries. We'll try to understand what is index. And synonym is just an alternative name for all the objects. So for table, an alternative name will be there. View, for an alternative name will be there. For sequence, alternative name. That is what is synonym. So let's start understanding how to create this table, view, synonyms, index, and sequence. Okay, so table. Now we've already understood how to create table, and you can see here what they have done. Create table department, department ID number 2, department name varchar 2, department trainer varchar 2, and table is created. And once they describe the department table, they can see that it is created with all the necessary columns. Correct? This is what is table. Coming to view. Now I've already told you that it uses some of the permanent table data and creates a temporary table for you for your own purpose. So create view imp info. Imp info is one of the view which you have created for your own purpose. What does this imp info contains? It contains select imp ID, ID number. It contains the employee ID, fname and lname concatenated, salary into 12, which is the annual salary. From which table? From employee table, where department ID is 22. So this particular query will be solved. Let me write it again. This particular query till here to till here will be solved. Whatever the output will come, that output table will be the part of imp info. So it's a view. It's just a window from where you are actually watching the original table. Okay. So it's just a temporary table for your own purpose. It's not a permanent table. Okay. It's just that from one table you are putting out some data and putting it inside a different temporary table for your own purpose. So select star from imp info is giving me, you can see here the imp info is nothing but will contain the data which is having department ID as 22 and with their employee ID, imp name, f name, and annual salary. These all things are coming here. This is what is your imp info, which is a view, not a table. And if you look here, if I want to use this imp info, I can use it. Select name, annual salary from imp info, where annual salary is greater than 5 lakhs. So I'm getting these all things. Now understand that this particular output is coming from this table and not the actual employee table, right? Cool, right? It's very cool. Okay, let's move to the next one, which is sequence. So if you want to create a set of integers like 1 2 3, which is automatically generated and supported by many databases systems, we can use sequence. How do we do that? Create sequence, sequence name, start with initial value, first value, whether you want it to be 0, 2, 4, 10, whatever. Increment by how much you want to increment, by a 2, by a 1. Minimum value should be how much, maximum value should be how much. Cycle, no cycle means whether the sequence of integer will repeat or not repeat. A very descriptive information about all those things. Sequence name, name of the sequence. Initial value is starting value. Increment value, by how much it will increment. Minimum, maximum value. Cycle means when sequence reaches its set maximum value, it again repeats. And no cycle means even if it reaches the maximum, it will go on. It will not repeat. So here is one of the screenshots. So you can see create sequence, sequence 1, start with 1, increment by 1, minimum value 0, maximum value 100, right? So this particular value will start with 1 till 100. Same way, increment by -1, minimum value 1, maximum value 100. So this is nothing but to do it in descending order because I'm doing -1. So starting from 100, it will go 99, 98 and goes on. Okay, coming to this particular portion, now you can see how we can apply the sequence to my table. You can see the name of my sequence is sequence underscore 1 and sequence underscore 2. This is what I've given the name to my sequences. Insert into department values. When I'm inserting any value to my particular table, I'll use sequence underscore 1 dot next val. Next val is something which gives the next value. So sequence underscore 1 next val will give me the first data. That means first sequence, right? So I'm getting 1 here. Sequence underscore 1 dot next val is giving me second. If I would have used here sequence underscore 2 dot next val, then it would have been start with 99, 98 like this, right? So this is what it is, your sequence. Let's move to the index. Indexes are a special lookup table that a database search engine can use to speed up data retrieval. Now, what are these? These are basically kind of a table which is used to actually make your task easier, because search engine can find these indexes very soon. Single column index syntax, multiple column index syntax, and unique index syntax. There is no change. You can see here that if you want to have a single column index syntax, we'll write only one column. Multiple column index syntax, we'll write 2 column or 3 column. And then unique index will have unique index. The same syntax will be there. An index helps to speed up select queries and where clauses, but it slows down data input. With the update and insert statements, indexes can be created or dropped with no effect on the data. Okay, create index DEPTT on department ID. So I'm creating an index for the department ID column of department table. Index is created. Create index department 1. I'm creating an index for department 1 on department, which are columns for department ID, department name, and department trainer. I'm creating a unique index. So this is single, this is multiple, and this is your unique one, right? So I'm creating a unique index department 2 on department only for department name, right? So this is how you create an index, and you can use this index whenever you want, but when it should be avoided, when the table is small. When the table is small, don't do that. The columns are not often used as a condition, don't do that. It's a waste of time, right? You have already tables, then why do you want to create an index? Column is updated frequently, so don't use index at that time. How can you remove an index? Just write drop index. If you want to drop the view, drop view. If you want to drop the table, drop table. And if you want to drop sequence, drop sequence. This is how you can actually drop any of the objects, whatever you create. Drop table we have already seen in the DDL statements, correct? Confirming indexes syntax. If you want to confirm whether we have that particular index or not, select star from user index. If you do this, all the indexes whichever you have created, the list will come up and show it to you. Select star from user synonyms. Whatever synonyms you have created, whatever views you have created, whatever tables you have created, everything will be shown to you once you write these statements. Okay, dropping index we have done. Select star from user indexes. You can see department 2 is now not there. So we have dropped the index, which is department 2, right? Synonym. What is synonym? Synonym is basically to create an alternative name for a database. That means for table, view, sequence, or procedure. For whatever you want to create a different name, you can create. So create synonym branch for department. Okay, that means for department table, I want to rename it to branch. I've created a synonym. I can use branch also to fetch the details of department table. In the same way, view can also have synonym. Create synonym basic info for imp info. Imp info was my view, do you remember? And we are changing it to basic info. Done. For sequence, remember we were having one sequence which was sequence underscore 1. I'm changing its name to sequence underscore number 1. And I'm using this and I'm still getting the values, right? Next one, for index, create synonym department ID for department. This was my first index, changing the name. This was my second index, changing the name, right? and thus your synonyms are created. You can see here, select star from user index when you are doing. It is not showing me the synonyms which I have created. It is actually showing me the actual name. Why? Because synonyms are not doing the permanent change. Synonyms are just synonyms. It's temporary for trial use or temporary use, right? So this was all about Oracle database and this was all about SQL. I